Hello? Welcome back. Oh God. Do we have an echo? Is the echo gone? Yes. Okay, great. Hello. Welcome back to the second day of Bang Bang Con. I had such a great time yesterday. I'm so excited that we're back. I'm so excited for all the talks today. And before we get started, I wanted to do a very quick recap of yesterday's incredible talks. All right. So very, very quickly, here we go. We had this incredible keynote where we got to see this adorable elephant watering can among many other wonders. There was the taming of the clue, teaching a pen plotter to solve crossword puzzles. With this pen plotter, I actually impulse bought a pen plotter after the last Bang Bang Con, so beware. It's a real danger. We had little printing for everyone, where we got to see this adorable tiny printer make these adorable photos, and they put their pen plotter on the internet. Their little printer on the internet. We had printing floating point numbers is surprisingly hard, as you see in this slide. We had bringing back my 1998 by building an Arduino that can recover a PlayStation memory card. I think one of the lessons here was to use your brother's first, so that you don't ruin yours, but don't tell him, something like that. Trapped in code points no more. I'm bringing Chinese characters with this really amazing demo that I want to play with to learn a little bit more about Chinese characters. We have reverse your ski goggles for fun and profit with some famous last words about reverse engineering hardware. We had playing Breakout inside a PDF where we learned how to write JavaScript to play Breakout with a very large number of text boxes. We had Obelisk and the Unknown Unknowns, or the art of fumbling through your side project to create something incredible, which was a really lovely meditation on side projects. We had Punch Card Love, a very personal history of computer dating. We had Let's Implement DNS to Learn History, where I learned about the chaos class instead of the internet class. We had recreating photography of the 1850s in a digital world, Cowboys principal component analysis, and One Vengeful Volcano Spirit, which really delivered on its title. We had email with the best ASCII art, which definitely won the best ASCII art award. Maybe there'll be more competition today. Who knows? We had supercharged Dijkstra's computing shortest paths on large road graphs in microseconds, where we learned about Dijkstra's algorithm and how to improve it and make it go orders of magnitude faster. And the last thing we had yesterday, before today's talks, was Quebec's 735 kilovolt power lines can survive the apocalypse, but can they run TCP? Where we learned that the answer is yes, but that you should not. So those were yesterday's talks. It was incredible. And I just want to say a couple of words I introduce today's keynote speaker, which was yesterday was so amazing. And I was a little worried, honestly, before the conference, as conference organizers often are, because we made the call to run this conference online, and I think we really hoped it would work, right? And we worked hard to create an environment where it would be a fun conference, and where so to me, Bang Bang Con is a little bit like programming Christmas. It's somewhere where you get to come and enjoy all of these amazing talks and celebrate with this group of people at the conference. And I didn't know if it would feel like that and if it would be like that. But we tried to make the space, and we invited you all to come, and it has been kind of like programming Christmas. It's been wonderful. And so thank you so much to everyone who came to the conference, for making it what it has been, and of course to all the speakers for giving these incredible talks, and to everyone today who are going to give more incredible talks that we can all be excited about. And if you're watching on the live stream and you don't have a ticket, please, I hope you enjoy all of these talks as much as I have. I really had a great day yesterday. Okay, so we're going to start our first keynote presentation of the day today. So I'd like to introduce Allison Parrish. Allison Parrish is a computer programmer, poet, and educator, and game designer whose teaching and practice address the unusual phenomenon that blossom when language and computers meet. She's an assistant arts professor at NYU's Interactive Telecommunications program, where she earned her master's degree in 2008. And perhaps less importantly, she is also a friend of BangBangCon and has spoken at BangBangCon many times before. And I'm so excited to see another one of her incredible talks. So welcome, Allison.
Okay, thank you. Let me get my screen going here. I'm hoping everyone can see my slides now. So my name is Allison Parrish, and this talk is called Computational Stickography, or Connecting Lines. I am an assistant arts professor at New York University in the Interactive Telecommunications / Interactive Media Arts program. And I am overjoyed to be here today. BangBangCon is an amazing conference. This is actually my 4th time speaking here, believe it or not. And it is an honor to deliver one of the keynote talks this year. I'm looking forward to luxuriating in the extra time that I have instead of just 10 minutes. Thank you to the organizers and to, whoops, oh no. Sorry, I'm trying to move this like weirdo little thing. Okay. There's like a little doodad on the screen that's in the way of my notes. Okay. So thank you to the organizers and to all the other speakers and to everyone in attendance for helping to carry on this really important event this year. So I'm a computer programmer and a poet, and I'm here today to talk about something that I'm enthusiastic about, which is lines of text in particular. In fact, an interest in lines of text is one of the things that poets and computer programmers have in common. And in this talk, I'm going to share a little bit about why I think the line is so interesting, and then show some of the projects I've been working on that engage with the line as a unit of text. So line 1 between poets and programmers. The importance of the line to poets may already be clear to you. It's widely understood as the fundamental unit of poetry. As the poet James Longenbach puts it, poetry is the sound of language organized in lines. More than meter, more than rhyme, line is what distinguishes our experience of poetry as poetry rather than some other kind of writing. Poets make use of the line in a remarkable variety of ways. Just a few examples: Emily Dickinson's lines that carefully interweave rhyme, clause, and punctuation; William Carlos Williams' lines that have tense and dramatic enjambment that break syntax across lines; Nerbese Phillips' near ejection of the line altogether in favor of more free and expressive layout in song. You can make rough taxonomies of how poets use the line, but no formalism can entirely capture all of these techniques. Just as a quick review of terminology so I don't lose some of you, the word that poets use for the way that a poem is divided into lines is called lineation. Frustratingly, this is also a term of art in geology, so whenever you search the library database for lineation, you get a lot of results about sandstone. Another common term is enjambment, which is a technique for lineation that involves introducing line breaks in unexpected places, like in the middle of a sentence or the middle of a word. While researching this talk, I discovered from the Oxford English Dictionary that you can also say this word in a fancy French way, enjambment, which is a nice way to feel learned and important, so I might say it that way for the rest of the talk. Programming isn't all about lines the way the poetry is, but programmers do deal with lines a lot in their course of work. The line is, of course, an important mathematical abstraction used in both computer graphics and statistics, but the line as a unit of text is actually equally important to computer programming. Code is conventionally written in plain text files, which are sequences of characters delimited with the line break character. Version control software like Git uses the line as the atomic unit of change. When you apply a patch to a file with Git, you're applying that patch based on lines of text, not some other unit like characters or bytes or functions or parts of a syntax tree or anything like that. Dozens of Unix data processing tools like grep, sort, head, tail, cut, all use lines as their fundamental unit of processing. So poets, programmers have in common this interest in the line as a unit of text. Line number 2, ASCII and stichometry. But code isn't the only part of programming where the line pops up. The line is also the go-to unit for organizing data. Many file formats, both official and ad hoc, make use of the line break, the ASCII line feed character, as a record delimiter. This is, on the slide you see, an example of data in CSV format in which the data is stored in a plain text file, and each datum, each line of data, is stored as an individual line. The line feed character is arguably the most popular way to delimit records in data, despite the fact that the ASCII standard actually has included from its inception a control code specifically set aside for separating records, hexadecimal 1E, the record separator control code, which I've highlighted in this list on the slide. But nobody actually uses that record separator control code to separate records. And I think a reason that people use the line feed character instead is instead, even when there's this like tool that's been set apart specifically for that purpose, not like ambiguously the way that the line feed character is. The reason that I think that's the case is that the spatial metaphor of the line is just too well established. Like, we already think about data in terms of lines, so it's difficult to resist using the line feed character for that purpose. The visual line, as much on a sheet of paper as on a computer screen, is already used everywhere as a way of organizing information. The convention of having rows of data arranged vertically from top to bottom by time dates back to pen and paper ledgers, and even as far back as ancient Mesopotamia. There's on the right there, you see a cuneiform tablet that's showing tabular data from 1295 BCE that looks exactly like a spreadsheet. And arguably, maybe it even goes back to the origin of writing itself. So the line break is already a record separator. We didn't really need a separate character for that. Lines are a way of organizing information, but they're also likely the earliest unit used to measure text itself. Ancient Greek scribes divided text up into lines and then counted those lines up in order to better catalog text and to make it possible to refer to sections of text by their parts, sort of the original page number. And of course, that would be useful with scrolls where there aren't pages. This process of counting lines is called stichometry, from the ancient Greek stikos, which means a row of soldiers or a line of poetry. One scholar I read argues that the stichometry was the birth of text analysis and corpus linguistics, saying that segmentation of text into formal semantic and later syntactic units, not related to the physical data carrier, was at that time a great achievement and allowed future generations of philologists and grammarians to create the first real corpus and statistical tools, by which I mean concordances and indexes. So the line may have been like the beginning of being able to do statistical analysis of text that leads us to things like TF-IDF and things like that today. The photograph in the slide shows a line number in the margin of a manuscript copy of a text by Plato. That's from the 9th century. In ancient Greece and medieval Europe, books were often cataloged by name and line count, and book buyers used the line counts to ensure that the copies they were buying were complete, sort of an ancient checksum technique. The image on the left is a list of books in the Codex Claromontanus from the 5th or 6th centuries CE, Common Era, in which the titles of various Christian texts are listed next to the number of lines in the corresponding text in Roman numerals. To me, this looks a lot like the output of the Unix word count command, WC-L, with the line count option enabled. So stichometry is alive and well in the 21st century on the command line. Another interesting, fun parallelism between ancient scribes and computer programmers is that, according to this often cited paper by J. Rendell Harris, scribes in ancient Rome were paid by the line, and also programmers, of course, their productivity has in the past been evaluated based on the number of lines of code that they write, and the image just shows a paper that I found about using lines of code as a productivity metric. Lines are one of the ways that language becomes data, and wherever you have data, money isn't far behind. Next line is between linen and cannabis. Earlier I mentioned the etymology of the ancient Greek word for line, stikos, which also is the word for a row of soldiers. And that actually comes from the same Indo-European root that gives us the English word for stairs, because you're walking up them, you're climbing up them. In an alternate reality, the word for line, poetry in English might have been a stair of poetry, which I think is interesting. But the word for line in English ultimately derives from the word for the flax plant, which produces a fiber that remains rigid without having to be held taut, like other fibers need to be. That is, a flax fiber is on its own a straight line. To me, this etymology of the line explains the main metaphorical difference between a line and, say, a rope, a cord, or a string. Straightness in nature is the exception and not the rule. A rope, a cord, or a string becomes a line when someone holds it taut and rigid, like a linen fiber, thereby removing the slack. Likewise, with the ancient Greek word, a row of soldiers stays in formation only through discipline. You have to exert effort in order to keep the line straight. In computer programming, we use both the words line and string to refer to sequences of characters, but they're not interchangeable, and I think there's a reason that we call it the command line and not the command string. A string can contain an arbitrary sequence of characters, but a line is text that has already been set apart as having some intention, a record in a file, or user input in response to a prompt, or something like that. While I'm on the topic of etymology, one of my favorite topics, I'll point out that the English word read originates from a word that means govern or counsel. The word file comes from the Latin word for thread. So a fair etymological and metaphorical translation of reading a line from a file is governing a thread by pulling it taut. One more etymological aside, just as the word line comes from the word for flax, the word canvas is cognate with the word cannabis, a plant whose fibers are often used to make durable fabric. So the next time you are using JavaScript, say, to put a line on a canvas, you can think of it as like gently setting a flax plant on top of a cannabis plant, which I think is a nice image. The next line that I want to draw is between oxen and typewriters. Getting back to literature and writing more specifically, in the history of the written word, you can actually distinguish two different kinds of line, the graphic line and the poetic line. The poetic line is also called a verse. A graphic line is just what you call on a writing surface when you see a number of glyphs placed in sequence, sharing the same baseline as they progress across the writing surface. In some writing systems, glyphs and lines are arranged from left to right, in others from right to left, in others still top to bottom, and then moving across the page from right to left or left to right. This image shows an inscription on a fragment of stone plate in archaic Cretan script written in boustrophedon style, in which characters and lines alternate between being arranged from left to right and right to left. And you can actually see that the orientation of the characters change as the writing progressed from the top to the bottom. Boustrophedon means in the manner of oxen plowing, because you get to the end of one row and then you move back to the next, starting from where you were. The graphic line, I think, originates just as kind of like a side effect of the need to adapt media of different dimensionality to each other. We tend to perceive speech as a one-dimensional medium, a sequence of sounds and words. Most writing surfaces, on the other hand, are understood to be two-dimensional. So when you're writing speech onto a writing surface, like a scroll or a sheet of paper, you have to find some way to fold the one-dimensional sequence onto the two-dimensional surface in as efficient a manner as possible. And that's what a line is. It's a way of like folding one-dimensional data onto a two-dimensional surface. In this slide, I'm showing a Hilbert curve as an example of another way to fill a 2D surface with a line. No writing system that I'm aware of uses Hilbert curves to lay out text on a page, but I think it would be cool if there was one that did do that. In purely oral literature, by which I mean literature that isn't written down, poetry also has lines. In this case, usually where a line ends is determined not by space limitations of the writing surface, of course, but by metrical, phonetic, syntactic, and semantic characteristics of the words themselves. What's interesting to me is that when poems from the oral tradition were first written down in antiquity and in the Middle Ages in Europe, for example, apparently there was no consensus that one poetic line should correspond to one graphic line. Instead, you see a variety of conventions for separating poetic lines in manuscripts, including things like placing a point after the last word in a verse, putting spaces in line between verses. We'll see an example of that later, or using capital letters at the beginning of each verse. Catherine O'Brien O'Keefe points out that the technique of starting verses flush with the left margin and leaving blank space up to the right margin for a single verse was maybe used only as a last resort in medieval manuscripts because it was a waste of the expensive writing material, leaving all of that expensive, expensive vellum, you're leaving it blank. So that thing that we think of as being the usual way that lines of text are written, especially lines of poetry are written, where you have one graphic line per poetic line, is actually not the only way that you do it, and it's kind of something that's only become the standard in a contemporary modern context. In fact, we still use graphical conventions like putting a point after the last word in a verse when we use the slash character to separate lines in poems or lyrics when you're quoting a poem or a song in line in prose. As far as I can tell, it wasn't until centuries later that the conflation of the poetic line with the graphic line became as universal as it is today. And I might argue that the conflation was only truly complete after the invention of the typewriter, a technology that allowed poets to essentially typeset their own texts and quickly experiment with how lineation affected the process of reading and composing poetry. The poet Charles Allison, in his well-known 1950s manifesto, Projective Verse, basically claims this and says, the line is equated with the breath, and the typewriter is the first technology that the poet has had that allows them to indicate their breath as precisely as they want to on the written page. The next line is between tidiness and fleshiness. So taking all of that into account, we've seen the line in many different forms and contexts. So what makes the line such a powerful and persistent unit of organization in text? On this question, I think the poets themselves have some good answers. The most elegant formulation about the line I've come across in my reading and research comes from the poet Lynn Heginian, who writes, "The line affixes detail to time. The writing of the line begins as an act of observation, and it is completed by recognition of the thought that it achieves there." I understand this to mean that in the process of translating sequences to surfaces, the line is how a writer notes detail in anticipation of how the reader will approach and perceive the text as it unfolds in real time in the process of reading. The line is how a writer draws attention to particular characteristics, or in Heginian's terms, particular observations of the language in question and how it operates. The poet and scholar Johanna Drucker emphasizes not the temporal aspect of lines in time, but instead their visual and spatial aspect. She writes, as visual forms, the lines create their own order in the text, a frame which introduces the struggle of hierarchy into the words. The breaks become a force against which the whole must be recovered, or against which the whole can be fractured, dissolved, let go. The visual line strains the literary authority with its vulgarity, its crudeness, its fleshiness, which pollutes the material of pure language. Drucker is arguing here that the spatial layout of text on the page has its own significance, which demonstrates that written language is never simply a straightforward transcription of speech, but something more that has its own affordances and operates with its own conventions. In other words, a text always carries traces of the fleshy physical world with it, not just the decisions that the writer made in adapting language to the visual form, but also the material of the page and the physical gestures of the writing process, whether that means the writer's penmanship or their keystrokes or any of the other things that go into producing a physical text. Finally, Ron Silliman, the poet Ron Silliman, wrote this. which I think is like important for talking about the line as it regards computer programming. The line is the sole unit of punctuation whose use historically has not been determined by its potential for submitting chains of words to the hierarchic orders of logic, descended from the classical grammars of Greek and Latin, which have become our normative contemporary model for clarity in writing. In other words, one role of the line is specifically to cut across grammar and syntax, especially when grammar and syntax alone don't give us the expressive tools to do what we need to do with the text. All of these statements about the use and lineation of poetry apply equally to the use of lineation in computer programming. Most programming languages understand their input as just an unbroken stream of tokens from which any characters representing visual layout, like spaces, tabs, and line breaks, are stripped before the program is compiled or interpreted. Nevertheless, programmers make use of visual layout in their source code, and line breaks in particular, in order, I think, to affix detail to time and make the source code more readable for themselves and for other programmers. What's considered readable code is, however, highly conventionalized and often algorithmically enforced with tools like linters and autocomplete. In this animation, I'm using the P5.js web editor to make this creatively formatted code more tidy, in the word of the editor. In my experience as a programmer, and maybe in your experience, I've found that not all code is made more readable by adhering to convention, and sometimes there are bits of code that require unconventional lineation in order to make their inner workings more evident. Sometimes as a programmer, you have to enjamb your code. And many programmers also know that readability can be an arbitrary concern, which is among the reasons that the International Obfuscated C Code Contest exists, in which contestants often make use of line breaks and layout towards more aesthetic ends. This is Edward Giles' entry from the 2019 competition that has little waves. The code is broken up into these little waves, which I think is nice. It actually is a program that applies reverb to a wave file. Even in a language like Python, which is somewhat unusual by virtue of the fact that white space is actually a part of the language's syntax, Python still provides so many resources for creativity and expression with line breaks that entire PEPs have to be written in order to guide people in the right way to do things. As with other languages, there's even a module, probably many different modules for automatically reformatting your code in order to conform to these conventional standards. Personally, as a poet and a Python programmer, I would never use one of these libraries because I have too much fun playing with the layout and making the layout do exactly what I want it to do inside of a Python program. So that's some historical background. With that in mind, I want to talk, and speaking about Python programming, I want to show off some of the stuff I've been working on recently that concerns lines of poetry. As a poet, I've been interested in putting the idea of lines as freestanding textual units to the test, removing lines of poetry from the original context and then figuring out ways to juxtapose them in unusual ways. This sort of line of research started a few years ago when I made something that I call the Gutenberg Poetry Corpus. That corpus consists of around 3 million lines of poetry generated from Project Gutenberg, which is a database of texts that are in the public domain, around like 70,000 books that are in public domain, that are all available in plain text format that makes them really easy to manipulate for text analysis and creative purposes. To build the Gutenberg Poetry Corpus, I wrote a program that goes through all of the metadata in Project Gutenberg, finds all the books that are listed as poetry, and then I scan through those. My program scans through them line by line, extracts line of text that look like poetry, as opposed to introductions or commentary or footnotes or other paratexts, and then collect them together, and it ends up being a 52 megabyte file that contains 3 million lines of poetry from all of the included books in Project Gutenberg, or at least the books that were in Project Gutenberg a couple of years ago, as of a couple of years ago, along with a number that identifies the volume that it originates from. This is actually stored in JSON format, but the particular kind of JSON format where you separate JSON records with a new line, which I don't even know if that format, it's used all over the place, but I don't know if it has an official name. This is a diagram of the process of creating that corpus. The most sophisticated part of the code is the rules to determine what counts as poetry, which is just a bunch of ad hoc criteria that I'd eventually like to replace with something more well-reasoned. But this program works pretty well and does what I want it to do. The corpus, just to give you an idea of what it looks like, this is an animation of what happens when you make a program that just prints out lines at random. So it's just like a big stream of lines of poetry that have been taken out of their context. Actually, the reason that I made the Gutenberg Poetry Corpus in the first place was because I was teaching a creative writing class in 2015, and I wanted to give my students an assignment to write autocomplete poetry, which is usually you go to Google and you type in some words and then you make a poem from what Google suggests after what you typed. But I didn't want my students to have to use Google to do this if they didn't want to. So I made a quick tool with Nginx and Redis that sort of works like Google Search Autocomplete, except it autocompletes your typing with a line of poetry from the Project Gutenberg Poetry Corpus that starts with the same letter. So you can search through it and it completes it with the line that matches that prefix. This is actually, I believe, still online. It's 5 years old, which is an eternity in online art project terms, but I think you can still go there and use it. Once I had that corpus, other applications started to suggest themselves. The poetic line, as we've discussed, is often determined by sound, meter, rhyme, assonance, alliteration. These are things that like set one line of verse set apart one line of verse from another. Starting with this insight, I wanted to make a project that could sort, cluster, and juxtapose poetic lines based on their phonetic characteristics. Basically, what I wanted to do was, first of all, find a way to represent the sound of words as vectors so that I could draw like a scatter plot like this, where words with similar sounds like octopus and apocalypse would be closer together on the scatter plot, and words that are dissimilar like inky and kinky would be further away, even though they would be clustered together. So finding a way to like turn a word, the phonetic information of a word into a vector. To do this, I made a program using the CMU Pronouncing Dictionary, which is a database of English words and their pronunciations, which you need in English because the way that words are spelled doesn't really have much with how they sound. And then I wrote sort of like a weird kind of ad hoc feature detection manual feature extraction algorithm that uses bigrams of phonetic features in order to produce a big matrix of counts of features, used principal components analysis so that I ended up, for every word of English, a single 50-dimensional vector that represents the sound of that word. I used that same algorithm then to get a 50-dimensional vector for every line of poetry in the Project Gutenberg corpus. So I had for every line of poetry, I had a number, a coordinate in space that indicated the sound of that poem. And with that, I made this book called Articulations. This is a book of computer-generated poetry. It was published by Counterpath Press 2 years ago as part of Nick Montfort's Using Electricity series, which consists all of the books in the series are computer-generated. And I've included an example of the output here. I don't have time to read it, even though I love reading it. So the book is composed of an automated random walk through the phonetic space of the Project Gutenberg poetry corpus. I start with a random line of poetry, and then I find the line that is most phonetically similar to it based on its calculated vector, and then add that to the output, find the line that's most phonetically similar to that, add that to the output, and so forth, excluding any line that has previously been in the output. The end result is this kind of poetry where cohesion is achieved only through phonetic similarity. And one key decision here that has to do with the topic of this talk is that I decided to format the output as prose by running the lines together into paragraphs. instead of retaining the original formatting of the lines. And my reason for doing that is I wanted to blur the distinction between lines and draw attention to how they're similar to each other. So that's one experiment with that corpus. A more recent project, which I'm calling variational sestinoid spirals. This is less about the sound of words and more about the meaning and syntax of lines of poetry, and the ways that machine learning can facilitate the invention of new poetic forms. Computer-generated poetry, of course, is a whole field of practice in computational creativity. You can get on Google Scholar and find, hundreds of papers about generating poems with computers. But the question I started out with was not how do I generate new poems, but how do I generate new lines of poetry? How do I make a generator that knows how to produce just a single line of poetry? What does it mean to write a generator that produces a single line? To do this, I made use of a kind of neural network architecture called a variational autoencoder, sort of akin to a GAN, in the sense that it is a model that kind of essentially learns how to compress data. The encoder produces a fixed length vector for each item in the training set, and then the decoder learns how to produce the original data from that fixed length vector. In a variational autoencoder, the values in the fixed length vector are constrained to conform to a particular statistical distribution. And the benefit of this is that the model becomes generative. You can generate new data that looks like the original data by picking random numbers and feeding them to the decoder. Similar random numbers produce similar outputs, and you end up with a latent space that can be explored. Coming up with the idea, I did not invent the idea of a variational autoencoder, and I'm only a beginner machine learning engineer, so I relied very heavily on the research from these researchers, from Junshen He, and Benjamin Heinzerling's pre-trained embeddings for byte pairs were also a big part of this project. I should also note that I was super inspired by Robin Sloan's sentence space project from a couple of years ago, which you'd look at, and I have a link to my fork of the variational autoencoder code that you can actually launch in a Jupyter Notebook in your browser if you want. So once you train this model, you end up with a model where you can feed a random number into the decoder and get back a line of poetry. Part of the reason that I wanted to do this was to be able to explore poetry space. Last summer, Runway funded my work on this model, and part of the reason that I wanted to make it so that I could use their latent space explorer in the Runway app. What you're seeing here is a single sample from that space surrounded by samples that are from similar numbers, and you can sort of move over it like Google Maps. So each box contains a line of poetry that is generated by the model from nearby points in that latent space. Once you have a model like this, there's all kinds of fun stuff that you can do. One is creating interpolations between two different lines of poetry. So you encode one line of poetry and encode another line of poetry, and then decode from points along the line that connects them, the line that connects them. So this is an interpolation from the first line to the last line of Robert Frost's The Road Not Taken, taking a more direct road from the beginning to the end of this poem. So this is sort of like the result of drawing a line through a latent space of lines. It's like a meta line in a sense. When I showed this project on Mastodon, a user there suggested circular interpolations, meaning pick a random hyperplane and then decode from a circle drawn in the hyperplane. And using this technique, you get lovely lines of poetry that seem to return to where they started. And it's just a little interface I made in P5.js to explore one of these circular interpolations. The poetry generator that I made with this technique produces poems by sampling lines from points on concentric circles that gradually increase in size in the latent space. It follows a schematic that looks like this. Each circle represents a stanza, and as the circles get bigger, the stanzas get longer. In essence, each stanza is an elaboration on the last. I might read just a little bit from this one. This is a moment, that is a moment, full of a moment could be seen, that is made, that shows a moment, having been pure as a little heart was seen. That is made, that shows a moment having been full of a moment, still had seen her eyes, making a little heart of man. The present, that shows himself, however, that space of a moment had been gone, and sweet as a smile of beauty's eyes praised to my heart. The present that shows, perhaps, the latter of this moment, having been as sweet as thou shalt have seen his eyes. Sweet a mile of my heart is bright, only the heart. The latter that shows, perhaps, the books of being, having been for such a different hours had passed, and all shuddering with her fair eyes of her eyes, sweet a smile of my dear face, seeing the word, that is a moment. Which I like. I think that's a pretty good result. All of this finally brings me back to the title of the talk, computational stichography. So making that poetry variational autoencoder was fun, but at this point I've made so many projects with the Gutenberg poetry corpus that I'm getting kind of sick of it. Because it consists of poetry in the public domain, specifically in the public domain in the United States. It mostly consists of 18th and 19th century white male American and British poets whose poetics, by and large, let's say, are not especially expansive in subject matter or style. So a lot of what comes out of the variational model has a pretty monotonous diction. It all sort of sounds like a mishmash of Coleridge and Wordsworth, like falling asleep in your high school English class. So I could just make another corpus, you may say, but the issue is that this is the only corpus of poetry that I know of that is both freely available and entirely unencumbered by copyright. I could scrape the web or scans of books for contemporary poetry, but then I wouldn't feel like I had any real ownership in the output of the program, and I'd be obligated to seek out the permission of every poet whose work was used to train the model, and I don't have time for that. So the solution I'm pursuing is to find some way to introduce poetic line breaks into arbitrary text. That way I can use any kind of text to train, or at least fine-tune the model that I made. And if I wanted to, I could train a variational autoencoder to produce lines of poetry about flowers by grabbing all of the Wikipedia pages about flowers, splitting that prose into lines, and then use those lines to train the model, and then publish the resulting poems under the same license as Wikipedia. So I've made some progress on this, and I want to show you that progress. I'm using this word stichography to describe the process of adding poetic line breaks to arbitrary text. That term comes from biblical studies, where scholars use it to describe how scribes copied certain poetic or musical passages in scripture, not in the regular continuous script, but with graphic devices to separate poetic lines, like spaces or line breaks between the verses. Showing here an example of the same passage from two different scrolls, one in which the scribe has copied the passage in continuous script, and another in which the scribe has written the passage in a stichographic fashion, with the blank spaces to note the ends of poetic lines. These are written in line. These aren't line breaks. The lines are separated by spaces. The scroll fragment isn't from the same passage, but it shows what the empty spaces looked like in the original manuscript. So as I understand it, different scribes had different techniques for writing these passages stichographically. They applied a set of criteria to determine which passages should be written stichographically, but came up with their own strategies for performing the stichography based on their own ideas about how the text worked phonetically, semantically, syntactically. So what I need is to be able to do what these scribes did, but in an automated fashion, so I can do it on, thousands and thousands of Wikipedia pages. So I trained a machine learning model to do it. I treated this as a sequence prediction task. The input to the model is sequences of tokens from the Gutenberg poetry corpus, and the labels are either a 0 or a 1, with a 1 indicating that there should be a line break directly following that token. My theory is that most lineation relies on the sounds of words. So I used Pencilate to find phonetic embeddings for each word instead of using just like numerical indexes in a vocabulary. Pencilate, by the way, is the grapheme to phoneme model that I actually talked about in my Bang Bang Con talk last year. I think that using the phonetic embeddings makes the model more accurate. And it also makes it possible for the model to deal with out of vocabulary words or even like made up nonsense words, which is definitely a benefit. The network architecture is a stack of bidirectional recurrent neural networks. I know that everyone has moved on to transformers or whatever, but it took me like 2 years to understand RNNs well enough to be able to just like whip up a model like this on a whim. And I am planning to make the most of that investment. And I'm still working on this, but my little test models accomplished the task that I wanted to do pretty well, achieving 93% accuracy on my validation set. After training on my 2013 MacBook Air overnight, which isn't bad. I only like to make neural network models when I can train them on my laptop. So this is a video of a live typing interface that I made with an early version of the model. You type continuous text on the left there and get back text with the model's sticography applied on the right. The model does pretty well with these two light nonsense poems. Neither of these were in the training set. I never saw a purple cow and never hope to see one, but I can tell you anyhow, I'd rather see than be one. I eat my peas with honey. I've done it all my life. It makes the peas taste funny, but keeps them on the knife. So it does pretty well actually in finding reasonable line breaks in this text. As another proof of concept, this is some of the text from the Wikipedia page for zinnia, the flower zinnia, with the original continuous text there on the left and the model's sticographic output on the right. I think this is actually pretty good if you read over it. I think it's finding like, places to break the text that sort of fall in line with your expectations about where line breaks should go in poetry. I haven't actually used this to retrain my variational model yet, but that's the next step. So this is still a work in progress. So to conclude, what draws me to the line as a unit of language is that it's really the interface between language and the world. The line is language held taut, and someone has to be doing the work of holding it taut. So whether the line we're talking about is a poetic line based on rhyme and meter, or a line in a spreadsheet recording a single data point, or the line of code carefully crafted to elucidate or obfuscate the inner workings of a computer program, the line demonstrates that language is, in Johanna Drucker's words, fleshy. Language is always situated in physical and social reality. And that is my talk. Thank you.
Thank you so much for that amazing talk. Wow. Okay, so right now we have a break for 30 minutes until 12, where we're going to come back with our next session. If you're in the Discord, we have a few things you could do. You could hang out in the virtual conference space. We have a couches room and a kitchen room, and you could hang out there. We have a NeighborBot channel if you want to meet random people. You can get matched with random people to meet. I have seen that in the general channel, there is a spreadsheet party, which you can join, which I've looked at and it's very incredible. And if you're on the live stream and on the Discord, we'll be back at 12. See you then.
Hey everyone. We're still on break, but I just wanted to give my daughter an opportunity to say hi. She wasn't born last Bang Bang Con, so this is her first Bang Bang Con. Oh yeah, what's that? And happy Mother's Day to her mom. Very first Mother's Day. Oh, look at that microphone.
Ow.
Do you want to wear them? What do you think? She was just learning how to drink out of a cup. So we're a little, there's a lot of water going on here. Okay. All right. Say hi. Okay. Say bye-bye. Bye-bye. Thanks, Cindy. Back Hello, everyone. Welcome back to Bang Bang Con 2020 Virtual Conference Edition. I'm getting some echo, and it's because I have the live stream running in another tab. That's why I was getting echo. Problem solved by closing the tab. Yes, computers are difficult, but that's why we get to have fun conferences about the surprising and emergent behaviors of computers and running your live stream at the same time that you're trying to broadcast it, things like that. Thanks for coming to my Bang Bang Con talk. So we have a couple of talks coming up in this session. The first, it says here, I think I forgot to change the ordinals. There we go. Also, with the computers again. So really, it's our, let's see, 1, 2, 3, 4, 5, 6th session of Bang Bang Con. And we've got 3 amazing talks coming up. I think, before I intro those, I want to intro my background. My wife was running a live stream just prior to me logging on this morning that involved a lot of flowers. And I said, hey, why don't we leave those flowers up so that everyone can enjoy them? So that's why I'm sitting in front of a beautifully decorated backdrop here. Shout out to my wife and her mom who put this together. And I helped a little bit, but I'm not a very good floral arranger. Hopefully I am a better conference organizer. I think Franklin is in the chat or in the live stream. So if you want to pop on.
Hello.
Now my gain is too high. All right, let's turn that down. Thank you. Your notification just went away, but I just turned it down. So hopefully that's better.
Cool.
Good morning, Franklin.
Morning. Yeah.
Thanks for popping on to say hi. So let me see if I'm pronouncing this correctly. Your talk title is Learning Your IB Chi is translating Chinese into Morse code. I'm so terrible with tones, so I apologize if anyone who actually speaks any tonal language.
That was great. Yeah. Yeah. Thanks for the intro. We're going to roll the pre-recorded version of this, but I just wanted to say hi to the to say thanks to all the organizers. It's been a great conference, and looking forward to chatting more in Discord with everybody afterward.
Thank you so much.
Thanks.
Let's see this talk. I'm excited.
Hi, my name is Franklin, and today I'm going to talk about translating Chinese into Morse code. You're probably familiar with Morse code. It was the way of sending messages on telegraphs in the 1800s. The original encoding scheme really only contemplated characters from the Latin alphabet, so letters A through Z, as well as numerals 0 through 9. And it sent each of these as a series of electrical impulses that we represent here as dots and dashes. And as the telegraph network spread across the world, it was relatively straightforward to add new encodings for different alphabetic languages. And so you might have letters with diacritics that would be slightly different. But in 1871, when Hong Kong and Shanghai were connected to the International Telegraph Network, they had a problem. That being that Chinese is a character-based language and with thousands and thousands of unique characters. And so the same strategy doesn't really work. A telegraph operator working in English can memorize what A through Z are and can transcribe messages as they come off the wire. And that would be unfathomable to do for something like Chinese. So what ended up happening is that these first telegraph lines were built by European companies, being the Great Northern Telegraph Company of Denmark and the Eastern Extension A&C Telegraph Company of the UK. And since they were European companies in the 1800s, they naturally chose some Europeans to come up with the code. There were a couple of different iterations. The one that we're seeing here on the right is the Chinese Telegraph Code of 1871, which was put together by a French customs officer based in Shanghai named Viguier. And the general approach was that they took the most commonly used characters, and so starting with about 5,400 of them, although this grew up to about 6,800, and they mapped each of them to a 4-digit code, so 0000 through 9999. And if we look at a concrete example, if we take the character dong, which means winter, if you look that up in a code book, you'll see that it has the value of 0392, which then you can use the normal international Morse code representation to turn into dots and dashes. And I built an app. I have this link here. I'll have it at the end as well. That basically like steps through this, and so you can put in a bunch of Chinese characters, and it'll give you the corresponding Morse code. This has some implications. You might notice that with 4 digits, we can actually represent 10,000 things, and so we have quite a bit of extra room. These code books were arranged in a way for searchability, and so given a character, you could, based on its characteristics, find the right place in the book, and then look up what the digits were. When they arranged the book, they ended up leaving a bunch of extra spaces, which you can see here on the right, just in case in the future they needed sort of to add new characters that came into vogue without having to kind of reshuffle everything. The second implication is that this is actually fairly slow and verbose. So if we go back to the International Morse code, you'll see that this is actually arranged mostly for English letter frequencies. And so E's are very common and therefore very short, whereas Y's and Z's are quite a bit longer. And digits themselves are pretty long. If you're trying to send a single Chinese character that is represented by 4 zeros, then you're on the hook for 20 long dashes. And telegraph messages were also priced by length, and so you would be paying for all of that. So in addition, there was this kind of weird situation with plain text and secret messages. So in English, telegraph operators had developed a set of kind of special words that were not commonly used to represent longer phrases that they might come across. So if you got a message that said toothbrush, what this actually meant was that your telegram had been delayed in transmission. And this was great because it was less expensive, it was faster, but the telegraph companies were not a huge fan because this cut into their profits. So they developed a set of regulations where plain text messages were priced differently from secret ones where the sort of like meaning wasn't immediately obvious. And these prices were much higher per word. So as an English speaker, like you had a choice between, do I want to send this message as plain text or in secret? And while this originally had nothing to do with Chinese, it was kind of caught in the crossfire. Because Chinese was intermediated by these digits, it had no choice but to be priced, but to be lumped in with all of the secret messages, which meant that it was even more expensive. This problem ended up going away eventually. In 1893, the government of the Chinese Republic and the Qing dynasty negotiated a regulatory exemption and made it so that if you were sending a message with Chinese characters in a code book, then it would be priced as plain text rather than as secret, which is an improvement. So here we have the telegraph the telegraph code of 1871. It works, but definitely has some drawbacks. There were a bunch of different ways that people tried to improve on this, and I'm going to dive into one, which is referred to as trigraphs. So a trigraph is basically just a fancy word for 3 alphabet letters. As we noticed before, digits are pretty long in Morse code, but letters are much shorter. And so if we were able to map each Chinese character to a sequence of letters, then that would be a lot faster. And we can actually do better because we don't need nearly as many letters. We actually only need 3, which gives us more than enough space to kind of represent all the letters that we want. And so this is great. Going back to our example of winter, the trigraph of APB is much shorter in Morse code. And this isn't just a fluke. If we jump back to the website, we'll see that this poem originally in Morse code, in digits, when we switch over to trigraphs, is, I don't know, like half the length. And this is true for a bunch of different things. So that seems great. There was a catch, though. So when this was developed originally, Latin characters were not very widely understood in China. And so the codebooks had a mapping of Latin characters to Chinese ones that were phonetically similar. So instead of A, B, C, you had I, B, and Xi. And that was great because it meant that the operators could work entirely in Chinese. They could look up these characters like they were on the right. Each of those boxes has the trigraph kind of in the top left, and then the digit representation in the bottom left, and then the character itself on the right. Eventually, this mapping between Latin and Chinese characters became less necessary as kind of exposure to Latin letters was more widespread, and so eventually disappeared out of codebooks. And cool. So to give a very concrete example of, we have a phrase I like eating baos, which we have the conceptual equivalent in Chinese, and we can see that the digit representation in Morse code is fairly long, and with trigraphs, it's actually like probably just about the same length as the English phrase, which is pretty cool. So we've talked about two ways that Chinese was encoded to Morse code. Both of these had an intermediate step where they were translated first to digits or to trigraphs. And this extra step is still common. So 100 years later, if you find yourself trying to type Chinese on a computer or into your phone, it's actually not that different. You might be using some type of romanization. And rather than a person searching in a book for the right output, it's your computer, but we're still kind of a step removed. And Chinese is weird and different when you compare it to English or other alphabetic languages. And so that's all I have. Thank you so much. I encourage you to check out the app and play around with it. For non-Chinese speakers, I have a bunch of preloaded phrases and poems that you can kind of click around with and like get a sense for how this all worked. I highly recommend this book, The Chinese Typewriter, which goes into a lot more detail about both like Morse code stuff, but also just all the different ways that people tried to create a typewriter for Chinese, which has a lot of the same types of problems. And yeah, that's about it. Thanks.
Thank you, Franklin. I think we're going to do a quick sound check before we get started with our next talk. So, Tim, I don't know if you're on.
Yep.
Hey.
Okay, should I play it?
Yeah, play it. And I'll do your intro.
Could you hear that?
I heard like a sine wave of sorts.
An annoying tone. Yeah, that was exactly perfect.
Okay. All right, so then we're gonna just take a little bit of time to make sure everyone's ready backstage to get things prepared. Just double check, make sure everyone's ready. Okay, we're good to go. So our next speaker is Tim Holman, and the title of the talk is "The Making of a Mosquito." Tim is an Australian developer with a love for all things weird on the web. If you don't catch him hacking away at the world's most useless code, he'll be working hard on tools to get more people into generative art and feeling empowered to create. Welcome, Tim.
Okay. Hello, everyone. Welcome to my talk, Making of a Mosquito. Here are my details. I would love to talk about myself more, but we only have 10 minutes, so we got to get through it quick. But again, if you have ever seen me on the internet before or in any of my talks, you'll kind of know that I really want to get people into creating things. And I think it's the best way to learn and teach and grow and all around have fun. So the reason that I wanted to make a mosquito in the first place was to explore the web audio API. I wanted something not too crazy and not too simple to learn. The web audio API can be a little intimidating. It even mentions that in the MDN documentation. So I built this beautiful sanity chart to track my sanity over time. I like the chart at this point because it shows that sanity could potentially go above 1 when that is truly not the case. But with every project, you kind of just got to start with your building blocks. And for me, that is a small HTML page referencing a script. And in that script, I just have one single line to begin, let context equal new window.audio context. The audio context is how you access the web audio API. So if we were to look at my mosquito, and I just have to emphasize how much I truly despise this emoji, it would just be the audio context. Now, to get noise from the web audio API, you need a couple more things. I need an oscillator node and a gain node. And don't worry, I'm not going to owl you here. I'm going to go back and explain these. But the reason that I want to do it this way is because this is how I built it. And then I kind of reverse engineered backward towards making the mosquito. So if I had my code, I would have the context. I'd be creating an oscillator node. You can see that it comes from that context, that web audio context. I'd be creating a gain node. And then I would be connecting my gain node to the oscillator node. And I'd be connecting the context destination, which is the output, the speakers, to the gain node. And then I also have to add a button in because back in the day, we allowed playing audio and the world ruined it for everyone. So this would be my mosquito at the start. And this would sound exactly like this. A very annoying buzz kind of space noise. My sanity immediately started to go down. I immediately had to search how to reduce web audio API volume. And lo and behold, up comes the gain node. So we figured out what that does. It also mentions in the gain node, never change this value directly, but I never stopped to think if I should, and I decided that I will just change that value directly. And it reduced the volume to half. And that one that you heard just then was actually half already. It was really, really loud. So if we looked at my mosquito now, it would be an oscillator node, a gain node, and an audio context. We know what the gain node is, but what does this oscillator node do? Well, it turns out that the oscillator node is responsible for emitting a sound wave, much like this sine wave that you see here. And it has a few properties on it. It has a frequency, which is the frequency of the wave, and it has a type. There's a bunch of different types of waves that it can emit. And of course, a mosquito would be the most intimidating sounding type, which is the sawtooth. And then I did a little research into frequencies of mosquitoes. And there are a lot of videos online, upsettingly. And I also kind of learned that you could just jack the frequency up to about 10,000 and make that noise that only dogs and small kids can hear. Do with that information what you will. So I played around with my oscillator node. The sawtooth, again, was the best node type for this. And I set the frequency to about 750, and that gave me a mosquito that sounded a little like this. Very annoying. I had to reduce the volume again straight away. Sanity is at an all-time low of 0.8. The graph has figured out now that it's not going to go above that. But this mosquito I would call the base mosquito. It's the yarn create mosquito, the npm init mosquito, the user bin mosquito. That's where it would live. Sanity is falling at a rapid rate at this point. I've been playing with this for 30 minutes or something. I listened to mosquito videos. It was all kind of going crazy in my head. I decided that I need to stop the mosquito noise. At the moment I was refreshing. It was really difficult to debug. And the oscillator had a start and a stop. So I thought, okay, let me just plug that in to the mosquito. So I can press that button. I can press it again to stop. But at this point, I'd already closed all my tabs multiple times because I felt that I was still hearing the buzzing afterwards. I decided to add a clap audio noise to give me a small, brief moment of satisfaction. So there we had our clap and our ending of the mosquito. I decided to add in some ASCII art because I was really losing the plot. And then I found this. When I tried to start my mosquito again, it turns out you can't restart an oscillator node once you've called stop on it. I have no idea why. My best guess is that once you clap a mosquito completely out of existence, you can't obviously clap a mosquito into existence. So I had to do a bunch of different things here. I had to start the oscillator node when I initially clicked the button, and then otherwise I would disconnect or reconnect the gain node. My sanity, again, took a big hit here because I knew that every time I stopped the mosquito, it was secretly oscillating behind the scenes, waiting for its opportunity to strike. Now, if we think of the mosquito that I have at the moment, this, again, here's the noise. Well, you can hear the pain, you can feel the pain. The equivalent of that would really be a mosquito just kind of sitting, hovering above us at exactly the same spot, looking down. And although that would be intimidating, I kind of wanted to make the mosquito a little bit more bumbling and frustrating than the stuck mosquito in the sky. And between that frequency and type option, there was detune. I didn't really need to read what detune was because at high school, a lot of people played Wonderwall on their guitar, and I had great experience with detune. Now, my sanity is low at this point. It's below the 0.6 line that I call the insane or genius line. You know, I've set up my citronella candles on spraying everywhere. Oop, I'm in trouble for doing that. Okay. But I decided to build the Mesquite engine. And the Mesquite engine is what I was going to use to detune the mosquito. So if I were to just set that originally up on a sine wave, you can hear then that it goes up and it goes down as with the sine wave. Now that mosquito would just be kind of hovering up and down, which again would be intimidating, but not completely what I was going for. So I decided to, rather than completely just keep adding to the sine counter, putting it round and round, I decided that 25% of the time I would move backwards and 50% of the time I would move forwards. And the other remaining 25%, it would just stay static, which gives us this staggered Mesquite engine. I call Mesquite engine 0.5. And if you were to listen to it, you can hear that there it is much, much more like a mosquito. I felt that it needed a little bit more variance, so I added a small pusher and puller in the middle of that. This variable will just go up to 0.6 or down, and it would just randomly 50% of the time go up or down. That small little push looks like this. And if I were to attach that to the end of my already broken rotating Mesquite engine, I would have what I call Mesquite engine 1.0. Now, that is a mosquito if I've ever seen one. But now that I've got this Mesquite engine running the detune, why don't I connect it to all the pieces? If I connect it to the gain node, I can control the volume, and it can go up and down again with the mosquito. That is really starting to get onto the annoyance of the mosquito. And I thought, what else do I hate about mosquitoes aside from everything? And one thing that's really difficult about mosquitoes is trying to triangulate the noise when they're in your room or they're near you. You know, you're looking up, you're trying to find it, you want to get it. And it turns out there was one more beautiful piece in the Web Mosquito API called the stereo panic node. And the stereo panic node, which I'm going to connect to the Mesquite engine, of course, controls the left or the right speaker. Now, I'm not too sure if this will come over the stream, but this was my absolute complete mosquito. Infuriating. That is my talk. Thank you, everybody. Presenting this to you, of course, has brought my sanity straight back up to the top. Thank you for the time.
Thank you, Tim. Before we get started with our next talk, we're just going to wait a little bit and let everyone get ready. But one of the things I want to talk about when it comes to conference organizing for Bang Bang Con, one of the difficult and yet very, pleasurable experiences for us is the catering, getting that figuring out, do we have budget to do breakfast, lunch, and dinner? Do speaker dinner? All these different things we try to figure out. And of course, with the virtual conference, we didn't get to have the opportunity to do that this year. But for those with access to the Discord channel, we have a catering channel where people are posting some of the foods they're eating. And it's just like looking at these posts, it's such a delight. Just like going down this channel and I see, fluffy souffle pancakes, which I've tried to make several times and absolutely failed at. I see crepes, I see bagels, and it's just amazing to see like what all you different people are eating right now. There's a picture of a Monte Cristo with the bite. It's just fantastic. I love this channel. If people, if you have photos of things you're eating, please share them. There's donuts and coffee and French press. Oh my God. Let me see if we're getting ready for how we're looking for the next talk. Let's bring in Erdy.
Hey, I was just saying, you know, put me live and we can chat about the conference. I shout out to Du Jour Bakery in Brooklyn, who we had contracted, almost contracted, unfortunately, to do our catering, and then of course had to cancel. So whenever things get back to normal, shout out to them, and I hope they're all doing all right through this.
What I was really impressed about Du Jour Bakery last year is that they got up at around 4 a.m. to start the food prep. They made the donuts first that morning.
Yeah.
That day. It was just
everyone,
right?
Everyone who was here last year definitely got that treat of like very fresh pastries. So I hope you all get to treat yourself to something today, in remembrance of those delicious donuts. They also did. I'm gluten and dairy free, and they like did this whole extra like set of cakes that I could eat, and I was super happy with that.
That's awesome.
Yeah, they were like incredibly understanding of like everyone's dietary restrictions.
Awesome. Well, looks like we're ready for the next talk. I'm gonna introduce our speaker.
Awesome.
We'll move things. Okay, so next up is we have Tristan Hume, whose talk is titled "Using Font Shaping to Put Commas in Big Numbers Everywhere." Tristan Hume works on fast software at Jane Street. He gets captivated by funny and cool technical ideas and develops a burning desire to implement them, mostly in Rust, but sometimes in open type font shaping rules. He writes long technical articles about things he does and he finds interesting at his blog posts, which you can find in the speaker description of the Bang Bang Con website. Welcome, Tristan.
Hi. So I'm Tristan, and my job involves a lot of staring at large tables of numbers. And often I want to do something like look at this column of latency numbers in nanoseconds and pick out some larger quantity like microseconds and milliseconds. And this used to involve counting a lot of digits starting from the right of the number. And I found myself doing this in all sorts of different places, like my text editor and my terminal and Python notebooks and my web browser. And I didn't want to implement a solution for each of these places, but I came up with a weird solution that would work in all of these places, which is I could make a font that would insert fake commas into my numbers. And I could do this using font shaping, or at least I thought I could, because font shaping was really powerful. And I had seen all sorts of examples of really beautiful calligraphy and fancy Unicode tricks of various sorts. And so I have some examples here that I made by fooling around with the Unicode character palette for far too long, like this face here, made by combining characters to arrange things on top of each other. And so I thought I could do it. So I looked into the OpenType font shaping specification, which defines how all these things work. And so it says that things proceed in various stages controlled by tables within the font. So first, the characters in the string are mapped to glyphs, which are internal things used by the font, and then glyph substitution rules in the gsub table are ran on them. So these replace various sequences of glyphs with various other sequences of glyphs, for example, to do ligatures by combining glyphs together into a specialized ligature. Then this sequence of glyphs that's had substitution applied to it goes to the glyph positioning step. And what this does is it positions glyphs on top of each other in the correct location so that your accents are, for example, above or below the character. And at this point, everything is still just internal IDs used by the font, and it needs to be rendered by the UI system. And in this case, it needs to be translated to outlines. And these outlines for each glyph are stored in a table inside the font. And I was reading through the specification, and I started to get a little worried because everything seems to work from the start of the string towards the end of the string, and I needed to work from the end of the number towards the beginning of the number. Luckily, at the very end, I found the reverse chaining contextual single substitution rule. And what this rule does is it acts kind of like a certain type of regular expression. where everything is a glyph class. And glyph classes are kind of like regex character classes, where they match a set of glyphs that can be in a specific position. So there's the single position to replace and a glyph class of possible glyphs there and replacements for each of them, as well as look ahead and backtracking classes that match various positions around that glyph. And this rule type was originally designed for a type of Arabic calligraphy, and it was actually meant for doing left to right shaping on that type of Arabic calligraphy. But Arabic calligraphy is a right to left context, so in order to do left to right, it has to work from the end of the string to the beginning of the string. So in my left to right context, that's exactly what I wanted. It would work right to left. So font designers don't actually use the tables directly because there's some binary format. They use a language called font feature files, which compiles down to the tables. And here I have an example file. It has glyph class definitions at the top for lowercase and uppercase vowels. It says a feature that I want my rules in. These are just used for applying things in different orders or disabling and enabling things. And then it has my rules. My first rule finds a lowercase character next to another lowercase character and turns it into an uppercase character. The next rule takes an uppercase character next to an uppercase character and turns it into a lowercase character. And because these are reverse chaining, they start from the end of my string and make it so that there's no two cases next to each other, and so they alternate starting from whatever was at the end. And this kind of alternating capitalization is kind of like counting modulo 2 from the end of the string by using two different glyph sets. And we want to count digits from the end of the number, and we can use a very similar technique by using different glyph sets. But we only have one set of number glyphs, so what we need to do is create extra copies of the digit glyphs so that we can keep this state, because the only type of state in this substitution is by replacing glyphs. So we need as many glyph sets as we need to count glyphs. And as a digression, I decided that at first I didn't want to insert commas. I wanted to underline alternating groups of 3 digits. And the reason is that I wanted this to work in my terminal, which is a monospace context where every character has to be the same length. And inserting commas would mess up the fixed width tables and things like that. So in order to do this alternating underlining, I needed to count modulo 6, because that's the periodicity of this alternating groups of 3 digits pattern. So I needed 6 different glyph sets, meaning I needed to add 5 extra ones. So this is how the first version of number-to-line worked. The first character on the right of the number had no rules applied to it, staying as effectively glyph set 0. And then the next character after it had a reverse subrule that matched a normal digit following a normal digit and turned it into a glyph set 1 digit. Another character over, a rule matched saying that a normal digit next to a glyph set 1 digit gets replaced with a glyph set 2 digit. And this chaining pattern continues over the first 6 digits, and then the 7th digit isn't matched by any rule and so stays as a glyph set 0 digit. And thus, if I added more digits, the pattern would just repeat. And now that I have all my glyphs mapped to different glyph sets, I can then modify the outlines that are in the glyph table to change the style of some of these glyph sets. So in this case, I add an underline to glyph sets 5, 4, and 3. And this gives me my alternating underlining, at least in theory. Now I have to actually write code for it. And to do this, I had heard of this thing called the Powerline font patcher, which adds extra characters to a font, which is kind of what I wanted. So it was a good starting point, except for the fact that the font library it used crashed as soon as I tried to use a reverse subrule. And the reason is that it turns out nobody uses these reverse subrules, even for the type of Arabic calligraphy they're originally intended for. So they're broken in a few different places. Luckily, I did find a font library that did work. And so I had my tables that finally had underlines and alternating groups of 3 digits, making them easier to read. And so I went back to my original goal and I implemented fake commas by making some glyph sets wider and inserting a comma into the outline. I squished glyphs together to make this kind of visual grouping, and then I inserted little commas in between so I could have commas even in monospace contexts. Did other fonts, things like bolding, and then put them on a website for people to download and wrote a blog post. And someone saw this blog post and took it even further and wrote an implementation of FizzBuzz where it just adds numbered list elements, and these kind of magically become the correct FizzBuzz things. And it does this by implementing the divisibility rules for 3 and 5 that are based on the digits of the number as font shaping rules, and then basically implementing ligatures to replace those. I thought this was super cool. But I finally had underlines in all my places, like my pandas notebooks at work. And this was great. Now you might think this is a horrifying hack, right? And I don't actually think it is. I think I'm kind of using font shaping for something that it's intended for, or the same kind of thing, in terms of it's taking a raw representation of the text and applying stylistic rules to make it more easy to read and visually pleasing. And that's exactly the kind of thing that font shaping is designed for. It's kind of hacky insofar as I'm using it on ASCII characters that nobody expects font shaping to be applied to. So various apps sometimes do performance optimizations to disable font shaping for Latin characters, like Sublime Text and iTerm 2. So I had to switch terminals to Kitty to get it to work. But when it does work, it actually works really well and quite seamlessly, including like not having the fake commas when you copy the text. So I think this is actually pretty good. And I think it's a cool example of what you can do when you dive into a new level of the system that you might not have looked at before and find the right level to implement things. I could have done it in some kind of way involving some ANSI pattern matcher to work just in my terminal or a browser plugin, but I would have had to implement multiple different things and it just wouldn't have worked very well, and it actually would have been harder to do, even after the time I spent researching font shaping. So I urge you to go and dive in and understand new areas of the system that you haven't seen before. Thanks. That's all I have.
Thank you, Tristan. So up next, we have a break until 1 p.m. Eastern time for our next session. But in the meanwhile, I want to share some things that we have going on. Of course, there's NeighborBot, which if you have access to the Discord group, you can be mapped to somebody, connect with somebody at the conference, meet new people. We have voice channels that you can jump into audio conversations. And we have the virtual hangout space, and you can find the links to all these things in the general channel. We also have somebody created a Bang Bang Con spreadsheet where you can share fun and creative stuff. This is honestly one of the most interesting spreadsheets I've ever logged into. Check it out. For those that are searching for a job, we have a job search channel in the Discord group. But besides that, we'll see you in just a little bit. We'll take a little break. We'll recoup. We'll come back for another great session of talks. Thank you all for tuning in. Hey everyone, welcome back. It's 1 p.m. Eastern Time, and we'll be starting our next session of Great Talks. Up next, we have Helen Hou-Sandi, whose talk is titled Sparking Musical Joy at Home with Magnetic Stripe Swipe Cards in Tiny Code. I just read the bio sentence we have for Helen, which is Helen is the Director of Open Source Initiatives at the fully distributed agency 10up and a lead developer for the WordPress open source software project. When she's not deep in a code editor or polishing UX, she likes to make complicated food. I love complicated food. Hang out with her family and continue performing as a professional collaborative pianist. Please welcome Helen.
Hi, everybody. Hopefully you can all hear me. I think I have this set up correctly. You let me know if you do. I do have Discord open over here. All right, so I'm going to get started. He introduced who I am as a work person. So that's what I do. I do computer stuff by day, but I have my degrees in music performance, and I do still perform sometimes, also as mentioned. I also have 2 kids. They're ages 7 and 3 now, and they're equally opinionated and into music. I'm very opinionated. I mention them because they're important to this talk. So here's a question you'll hear from me all the time if you work with me. What's the problem being solved for? In my case, it's that I was spending a lot of my time being a human jukebox for my kids. The older one can manage a lot of things now, including voice assistants, but the younger one isn't quite there yet, and even if she was, our house can be very noisy, and 90% of people who come here are Spanish speakers, which gets confusing for devices set in English. I live in Costa Rica. My husband is Costa Rican, so that's why people here speak Spanish, and they sort of generally did before anyway. In any case, you should hear the things we have to do to get El Reino Infantil playing. The last time I tried, and I posted a video of this on Twitter, the last time I tried this, I got the reply, I couldn't find O Dreidel Infant Eel. We also have issues where the kids like some songs off of Just Dance, where they only play edited versions, but as much as I love her, there is no way I'm having my small children listen to an unedited version of Cardi B. So they have specific things they want to listen to, and I want to be able to tightly curate as well. I had seen this tweet go around, December 2018, and thought to myself, I should make that someday. So with Christmas the next year, 2019, approaching, and 2 months of school break ahead, because our school year here is different than it is in the US, it was time to solve my jukebox problem. So first up, supplies. One of the reasons I wanted to build this using a Raspberry Pi specifically is because I have 3 older ones I've gotten as speaker gifts over the years, and they're just kind of hanging around doing nothing. I ordered a couple more things off Amazon and had my very loyal spouse drive them back for me after one of his gigs in the US. I could probably have found most of this stuff locally, but electronics can be very expensive, and it takes a lot of phone calls and driving around to locate specific items. Here's what I used. A Raspberry Pi. It's in a little case that has WordPress stickers. Magnetic stripe cards, a card writer, which is the bigger one, a card reader, the smaller one, and USB powered speakers so they wouldn't have to have a separate power source. I forgot to include the speakers in this photo. I collected everything and I started testing components. First was making sure I could get Spotify playback on a Raspberry Pi at all. I have no idea what I'm doing. After a bunch of Googling, I decided to do this using Pi Music Box, which was super easy to install and get set up. I actually probably took longer trying to find a USB keyboard before realizing that a wireless Apple keyboard works just fine with the cable plugged in. And now the next part, making the cards work. My idea was to put Spotify URIs on the cards and have that trigger playback, right? Enter Spotify URI and have Pi Music Box start the track. USB card readers are basically keyboard emulators. You swipe the card and the data is sent to the computer as though you typed it super fast. I plugged in my card reader and I swiped an old bank card, just in case it was like trying to steal my data. And all I got were some numbers. So now I've worked in retail and I know that your name is also encoded onto the card. Here's what I was expecting to see. A card number, my name, some other information. Oh, it actually has a dash in my name. I wasn't expecting that. It's like a checksum / encoded information about like expiration, and then those numbers are actually repeated. But instead, this is what I would get out of my card. This is real swipes that I got from my card readers. And sometimes I would even just get this, right? So what's going on? It turns out I had a faulty card reader, of course. This would become even more evident way later on after everything was done because it occasionally sends ghost output and will randomly start tracks. I went to a couple stores nearby looking for a new card reader, but I couldn't find one, and nobody at those stores knew where I could even find something like that. So I did what all coders eventually have to do. I hacked around it. So magnetic stripe cards typically have 3 tracks of information, the first being able to store the most data, and the second and third only being able to hold some numbers, and it's like a limited number of numbers. I tried encoding Spotify URIs onto the first track, but between the card reader not reading the first track and Spotify URIs being case sensitive, which if you didn't notice, my name was in all caps, this was a no-go. My buggy card reader actually sent me down the right direction because otherwise I probably would have tried to figure something out involving the URIs because I was sort of mentally stuck on that. I decided I would encode just a number onto the second and third tracks. This also did not work correctly the first time. I guess maybe the amount of data is too small or something. So I had to encode each number with 3 digits, left padded with zeros as necessary, right? Our favorite thing, left pad. I also decided to encode the number onto all 3 tracks just to be like super sure that it was there. So now that this was working, right, I was encoding the card with the card writer with the number on all 3 tracks and then reading it with my card reader. So now that this was working, I knew what I had to do. I needed to have each number correspond to a line in a text file. But how do I make that text file and manage it? With hundreds of tracks, that could get very tedious very quickly. Well, a Spotify playlist made a lot of sense. I can keep stuff in order. You can select all and copy it as a list of Spotify URIs, which is actually pretty cool. And then I have the same list of music to play in the car or wherever else. I also just really love making playlists. So this is a screenshot of the playlist. I have a kids jukebox playlist, very dry naming. I can add more songs, I can add more tracks and change stuff up if like a track goes defunct, right? Like if I get geo-locked out of a track or if my kids get tired of a song, which happens with children. This gets copy pasted into a text file that goes onto the Raspberry Pi. You want to listen to this for Bang Bang Con? Okay. So now for some code, okay? The tiny code part of my talk. Taking swipe card input and making it play a song. I spent probably close to a week with the code editor open, and I was just staring blankly at it, like not even sure where to start. I overthought myself in huge circles, reading about people's Python-based setups and RFID chip versions and wondering if maybe this was all a mistake because I don't know what I'm doing. Until finally, one night, with the holiday looming, I wrote something, anything, and it worked on the first try. I could not believe it. This is my first run of code. It's literally 5 lines of Bash. I chose Bash for 2 reasons. One, I don't have to set up anything else like Python and any associated libraries, like for reading input. And 2, I'm actually pretty decent with Bash, especially after forcing myself to learn how to do Bash, write Bash by doing a bunch of custom things to my prompt several years ago. This code does exactly what it says, but there's a pretty cryptic Bashism, and I am the very liberal code commenting school. So I added comments to that Bashism, which is called parameter expansion, and the sed bit. This helps me and anybody else looking because, of course, as a director of open source, I wanted to open source this. Again, this code, it worked perfectly until I got to card number 8. And then I would get an error. I sat there stumped until suddenly all my years of dealing with loose typing in PHP washed over me. Octals. Since I was padding with zeros, when I got to 008 and 009, it yelled at me that that wasn't a real number. So a little more said to remove those leading zeros here on line 6. Then I wanted to add a special case card to toggle playback so my kids could stop music as necessary. Pi Music Box does come with a web UI, which I sometimes use to manage things from like across the house, but the idea here was to only use cards. This has been extremely successful, and my kids actually keep that play pause card at the back of the rack of cards so that they can always find it. Even the younger one has this down. She will look and get the card and pause playback. I decided to use 999 since I was using 3-digit numbers, and I don't have nearly that many cards, and I really, really hope that I never do. And then finally, my senior engineering mindset. Make sure you account for error cases. Here, I want to account for not finding a number in the input, as well as potentially not finding a corresponding line in the text file. And that's it. That's the entire script. 27 lines, including comments, and whitespace. It's tiny code. Okay, so now I have this Raspberry Pi able to play Spotify tracks off of cards, but it still requires me to log in and get things started. So how do I make it skip manual login and start my script on its own? That is, how do I make it headless? You don't have to worry about memorizing this. I have everything written out and available to you that you can refer to at your leisure. This is just to show you that it's honestly really not that bad. You download the file, set up the automatic login, and then make it run your file, your script on login. So everything was working. So now onto the assembly of the object. I went to a couple stores to see if any existing boxes jumped out at me as a good solution, but didn't find anything. My brother-in-law does happen to have a 3D printer, but I didn't have any particular design in mind, and honestly, time was running out. I poked around my endless supply of organizers because I'm a slightly compulsive organizer, and found these in my stash. Some modular stacking boxes from one of my favorite places, the Container Store, and heavy-duty double-sided tape. Seriously, this tape is not an ad, but this tape is ridiculous. I've actually since acquired a properly working card reader, but I can't pry off the old one, so I haven't actually replaced that part. It just randomly plays on the track sometimes. Anyway, a little cable organizing later, and ta-da! A compact little jukebox ready for gifting. But wait, I haven't talked about the artwork yet. There's stickers. I love stickers. Now that inspiration project that I talked about at the beginning also used stickers, but the creator wrote an entire React app that pulled the artwork for him and everything. I may be a programmer, but I am not made like that. So I returned to something I actually know how to use, which is a graphics editor. So shout out to anybody else whose formative web experiences include Paint Shop Pro. I made myself a template and then grabbed album art manually. Another reason why I decided to get art myself was because I didn't always want the album art that a script would grab. So for instance, for Mother Goose Club songs, I wanted to get a screenshot from the video for the song so that my then 2-year-old could identify the specific song she wanted, because as smart as I think my kids are, a 2-year-old is not reading titles and artists off of a label. I exported these as PDFs and headed to a nearby office supply store to have them printed out on adhesive paper, which I then cut to size and applied to the cards. I did everything in numerical order. You might have noticed I wrote a number in Sharpie on the back of the card in the previous picture. So that kept it easy, but also I very much believe in trust but verify. So I swiped every single card before applying the label. And yes, it includes BTS. So finally, I presented this to my kids and showed them how it worked. And after just a couple of days, both of them were masters of their new musical domain. I put it on a little shelving unit in the area between their bedrooms and completely on their own, I promise, on their own. They negotiated a queue system between them where they light up cards on the shelf for what they want to play next. They have absolutely loved their own little device. My 7-year-old loves to tell people that his mom made this because she's the best programmer, and it's just been all around joy watching them use a tactile device that brings them something that they love digitally. I hope you've enjoyed hearing about my first foray into hardware tinkering. I have everything that you need to get it going, including the sticker template and files to make the card making easier, available on my GitHub, where I'm just Helen. And here's a little demo for you, brought to you by my younger child. Thank you.
Thank you, Helen. Before we continue on to our next talk, I want to invite co-organizer Alicia to join me. Hey.
Hey, I can't stop smiling. That was amazing.
It really was fun. How are things going?
I'm pretty stoked. I can see, a lot of people are interacting with us on Discord and Twitter, and I'm just getting hyped all the time because I'm reacting to a lot of things here in the background. So it's amazing. People are retweeting things, they're posting more things. People on Discord are just like posting links all over, and I'm learning a ton. So yeah, it's been a lot of interacting and a lot of learning, and I'm really happy that we're doing this virtually.
What channel do you find yourself most checking most frequently on Discord?
When there is a talk going on, I usually just am in the talk channel and I see people reacting because that's super interesting to see what people are seeing. The one thing is that we as organizers see the stream a bit before everyone else. So there's this 20-second delay when I'm waiting for people to see the jokes, which is really fun. And other than that, I mostly just sit in the spreadsheet. That Bang Bang Con, party spreadsheet is amazing.
It's so awesome. Well, it looks like we're ready to continue with the next talk.
Yeah, awesome.
So we'll jump back. Let me introduce our next speaker. So up next, we have Julia Tufts, whose talk is titled Bang Bang, My Interpreter Shot Me Down. Julia is a software engineer based in Brooklyn, originally from Halifax, Canada. She used to study classical music and graph theory, but now makes bleeps, bloops, and bad wordplay. She enjoys imbuing abstract concepts with tenderness. Please welcome Julia.
Hi, hopefully you all can hear me. I'm Julia. I am quietly online under the Twitter handle Big Commitment, and I wrote a song about JavaScript and JavaScript interpreters, which I will play for you shortly. But first, a little background and context. So the inspiration for all of this was, what if I made a cover of Bang Bang, My Baby Shot Me Down, but made it about the Bang Bang operator in JavaScript instead? So why? A few reasons. One, I am committed to the full realization of terrible puns. And secondly, I was curious. Firstly, just like, okay, if I made this terrible pun song, what would that even sound like? What would the lyrics be? Who would the characters in this be? And secondly, it just got me thinking, like, how does a Bang Bang really work in JavaScript? Like, I have some idea of how it will evaluate, but really, like, what's going on? If I have this expression, like let some bool equal bang bang, some variable, I was really interested in digging into, like, what is this moment that, like, this final bang gets applied? Like, is it, I don't know, it just sounded like dramatic, and I wanted to explore that more. So, let's just review what a bang bang is. So, it's just two logical not operators together. So if you have your classic Boolean true, apply one bang, false, another bang, true. But it's a little more interesting in JavaScript land because you can apply this to anything such as numbers. So numbers will typically return true, except for 0, which returns false. Strings, shout out to Shark and her whole talk. Except the empty string returns false, and even objects. So, little one here. But this is a part that kind of like threw me because I was expecting this to return false, but it actually returns true. And actually, similarly with lists, an empty list will return true as well. So it seemed that, like, most of the time, like, it's true, but sometimes, most of the time it's false, but then sometimes it's true. So what's that about? So it turns out that, like, a bang bang will return true if the input is truthy, and false if it is falsy. And maybe you've just heard the terms truthy and falsy for the first time, so are like, did you just make that up? And no, it's a real thing. Someone else made it up. I'm just the messenger. So it's not too bad, though. So how we think about it is that there are only a set amount of falsy values. There's 8 in total. So they're the original false, 3 different flavors of 0, the empty string, null, undefined, and not a number. And anything else will be considered truthy. So now that we know a little bit about what a bang bang is, how does a bang bang work? How does it get evaluated, interpreted? So it turns out that computers are complicated, browsers are complicated, JavaScript is strange. But to answer this a little bit, so like your browser has a JavaScript engine, and the JavaScript engine will run that JavaScript. And every engine is a little bit different, but more or less they'll like parse, interpret, compile, and run. And in V8's case, I have this little aside. It's like, it'll try to optimize it, and then like there's this flowchart that's like, sometimes it like optimizes too much and then has to like de-optimize, and then like, but yeah, it's a wild world out there. But this song will cover this a bit more as well. And yeah, so, and V8 is the JavaScript engine that Chrome uses. And I chose to focus on that because it's open source. I can attempt to dig through the code and understand what's going on. So the song will be coming out shortly. So yeah, I was like, okay, what's the song going to be about? And so taking all of this and like digging through the code, I decided to focus on, okay, what if I am a JavaScript object? How do I travel through this engine pipeline, through this parser and interpreter, and how do I get evaluated as a Boolean? So that's kind of what the song is about. And I think the video will be ready to roll.
Hey everyone, welcome. Let me invite Alicia to join me on the stream. And thank you, Julia, for that amazing talk.
Did you see how awesome the live captioning was on this one?
It was incredible.
Yeah, there was all the sounds like whoomp and all the background. It's just amazing to have that. You know, I'm an ESL speaker, so English is not my first language, so it helps first with me understanding everything. But also as an organizer, I have to like jump between things all the time. And sometimes I don't catch everything during a talk, and I can just look at it and scroll back. It's amazing.
Yeah, I love the transcription with the music of the thud, thud, like the capturing of the notes and mixing it with the lyrics. Like,
and totally also, there will be a session with Mirabai today at Unconferencing. So if you are on Discord, you can join it and you can see her awesome setup and how she manages to do this so fast and all the shortcuts and everything. It's just mind-blowing.
Yeah, if you've seen Mirabai at previous Bang Bang cons, it's just like incredible, like the lightning pace. Like I thought I was a fast typer, but I am like not anywhere near.
Yeah. Nowhere near.
Let me see. Okay, looks like we are ready for our next talk.
Awesome.
So up next, we have Matt Claussen, whose talk is titled Repair a Commodore 64 in Just 64 Months. Matt builds software for journalists and is located in Newark, New Jersey. He enjoys studying the history of computing and learning the inner workings of obsolete platforms adored by millions. Please welcome Matt.
Thank you so much. And thank you to the Bang Bang Con organizers for putting on this conference and for creating such a welcoming space for new speakers like me and for everyone else. And yeah, let's get to it. Today, I just wanted to share with you like my multi-year saga of repairing my Commodore 64 that I found in the basement of a thrift store, buried in the dust and dirt. And just my experience of going from someone who had some basic working knowledge of playing around with electronics and someone who maybe has a little bit better of an understanding and appreciation for how these machines worked. So let's talk about the Commodore 64. For those who haven't used one before, it might be a little unfamiliar. This computer was released in 1982. It sold about 10 to 17 million units, depending on who you ask. And that puts it among the ranks of like the top selling computers of all time, I think. So when you turn this thing on, you just get this screen. And this is like a screen that represents a world of like infinite possibilities. What you're looking at right here is an interpreter where you can just start typing in basic code. Like the most common one is the 10 print go to 10, hello world kind of thing. You can just start going. Now you can also plug in cartridges in the back. There's a floppy disk attachment that you could use to load additional software. And I'm sure there were many, many users who never wrote a line of code or never created their own applications, but used the software created by others. And that's perfectly fine. That's perfectly great. But for those who wanted to learn the system a little bit better, Commodore provided a programmer's reference guide. And this guide would basically explain to you, like at a really low level, how all the hardware worked. And if you found that this game that you wrote or the software that you wrote in BASIC wasn't fast enough, well, their programmer's reference guides would also teach you how to write assembly code. And so instead of using an interpreted language, you could write assembly and get so much more performance and interact directly with the graphics hardware on the system. And really like a whole generation of programmers, grew up with this machine and it changed the course of their lives. And so why do I want one of these? Or why did I want one of these? I'm not quite sure. I was a little young to have ever used a Commodore 64 in its heyday, but I knew that it existed. And I especially knew that it existed by way of the demo scene, which is a really fascinating internet art subculture that I just really love. And a lot of folks in the demo scene also love this system. So I kind of wanted one too. Also, I had spent some time studying the architecture of the Nintendo Entertainment System and learning how that worked at a really low level. And that was a really rich and rewarding experience. And so I kind of wanted to do the same thing with the Commodore 64 because they share this very similar processors. And
I thought it would be interesting to compare and contrast how engineers, took like the same, like similar building blocks, but created like vastly different systems. And so if you look at these old computers and you compare them to computers of modern times, it's clear to see that everything has gotten smaller, everything has gotten more tightly integrated. And the way that we think about fixing these old computers versus fixing new computers is also drastically different. On the left here, you see an actual photograph of my board. You can see that 2 chips are removed because I was debugging and trying to determine faulty chips. And so I was able to do that with relative ease. And on the right, you see a MacBook Pro 16-inch model. And wow, that just looks so crazy. I don't know if I would ever try and fix a specific component on that thing. And I don't think most people do. Certainly, Apple, has some sort of refurbishment center, and I don't really know how that works. But your average like mom and pop computer repair shop probably would throw their hands up at this. Now, there are some exceptions to this rule. A fellow by the name of Louis Rossman, based in Manhattan, runs a computer repair shop, and he is like a wizard. He uses advanced microsoldering techniques, under a microscope, and he'll debug and he'll replace like the missing components and repair traces, and it's crazy. But most people aren't going to do that. If you look at a Commodore 64, you would notice that a lot of the chips and a lot of the components on there are bog standard, off the shelf, and it was possible for people back then to repair their own computers. They could buy these replacement chips. There's tons of 74,000 series logic, which is like a de facto standard of the time, and there's off-the-shelf DRAM chips. So if your RAM chip fried, you could, if you're lucky, it was socketed, and so you just pluck it out. If you're a little less lucky, you'd probably have to wrestle with a solder sucker, or if you're, maybe a little bit more wealthy, today, like you can use a desoldering gun, which kind of automates the process of removing chips from boards. And it's really important to note that even back in the 80s, Commodore provided schematics to authorize like warranty centers and also just their customers. If you opened up the programmer's reference guide that I mentioned earlier, you could you would see a folded up schematic that you could unwrap, and you would see how your computer was built. Imagine getting one of those now with your laptop. You'd be overwhelmed. And I was overwhelmed looking at this schematic when I got started. It's just, an insane amount of detail. And if you were, trying to fix your old computer back in the day, if you were lucky, one of those standard chips failed. But if you were a little more unlucky, maybe one of the custom parts failed. And that was kind of like your sign that you need to send this off to an authorized warranty center and, let them use their stock of like proprietary chips to repair your system. Today, we don't really have the luxury of buying new Commodore 6510, I think this chip number for the CPU. You'd have to harvest them from some other broken machine and you'd hope that one works. So lucky for us in the year 2020, information has been preserved and it's being shared online. And I think anybody who ever tries to repair a Commodore 64 will stumble upon this individual's website, which is just a goldmine of information. This Ray Carlson, I believe, was a former Commodore repair tech, and he has accumulated over the years tons of documentation, tons of reference material, and it's super critical and super useful for someone like me who is just getting started to be able to rely on the accumulated experience of someone like him. And it's just amazing to me that he has documented this so thoroughly and sharing it for free. So this is all well and good. And if you are experienced, you can sift through this information and you know what to look for. But I wasn't really experienced when I started out. when I got my Commodore 64 in the thrift shop, it looked like this, looked like in pretty good condition. But when I turned it on, I was greeted with not a very friendly screen. You might notice that this looks nothing like that friendly blue screen that we saw earlier. I did not dare use a video clip for this presentation, but if this were a video, you would see these colored dots wiggling and waving across the screen, and the computer was totally unusable. But that didn't stop me from trying to fix it. I took apart the computer. That's a thing that I kind of always do when I get old electronics. I like to clean them up. I like to make them presentable because I also want to use them. They're not just sitting on the shelf. I mean, they sometimes sit on the shelf for a little while, but every now and then I like to pick them up and use them. So here's what my actual Commodore 64 looks like when you take it out of the case. For a beginner, like, this is scary. What are all these chips on the board? What do they mean? How do they interact? And I used Ray's documentation, and I started, trying to get a sense for like what's wrong with this? Like, what part has failed? What parts have failed? I was completely, fumbling around in the dark. You can see here that Ray lists all the various chips and like their failure mode. What does it look like when this chip fails? And all I knew was that I had a black screen with dots on it. He calls them blank screens, and surprise, surprise, there are lots of blank screens. I was overloaded with information. I did not know what was important, what was not important. But I still tried. I went through chip by chip and tried to replace some things. One common thing that people recommend is piggybacking RAM. Basically just taking a replacement RAM chip and sticking it on top of one that you think might be working. And I did that, and of course that didn't work. The sound chip is notorious for failing on the Commodore 64. It's known as the SID. You might have heard of it. And sometimes when that chip fails, it prevents the whole system from booting up. So I plucked that out. No luck. There's another chip that fails a lot. It's called the PLA. The PLA is kind of like a switchboard operator for the system. And if that chip fails, then nothing will work. So I bought a replacement PLA from Germany by some guy, and that didn't work either. So I was just out of ideas. I decided to set this project down and, maybe come back to it when I could attack the problem with a little bit more rigor. What I was doing was akin to, if you had a programming project that you're working on and there was a bug, I was basically just changing random things and hoping that something would work. And just like that's no way to program, that's not really a great way to diagnose a piece of hardware that's faulty. So I spent some time working on other projects. I kind of upgraded my tools a little bit. I gained a better understanding for how they worked. And a few years later, I decided to come back to this project. And I decided to take a more, directed approach to figuring this out. And the first thing that you need to do to fix something is understand it. So let's take a look at the Commodore 64 circuit board and kind of break it down. Now, there's lots going on. You can ignore all those little like chocolate chip cookie type things, those little capacitors, and the other like passive components on the board. And we can focus on some of like the more interesting chips. On the top left, we have I/O. Those are two identical chips, and they are basically peripheral controllers. Next to them, we have a series of ROMs. They store things like the basic interpreter, the kernel that basically provides low-level functionality to the rest of the system, specific routines. A ROM chip that basically just has the character data, so like the actual text that you see when you type. The CPU, that's really important. We also have the SID chip that we mentioned before. Below that, the PLA, the RAM over to the bottom left. Of course, we've got a cartridge connector and the power section of the board. And in the middle, we have like the video section. So you can kind of see that these different components of the board, of the computer, live in their own little regions. And if we think about that, the physical layout of the board, we can kind of map that to the schematic. And so now we don't need to understand the whole schematic in order to, attack this fix. We can maybe take a more directed approach, and we can focus on just the information that's important to us at that time. Now, I don't have any specific like diagnostic equipment for the Commodore 64, although it does exist. So I didn't necessarily know that, for instance, all of my RAM was working and that all my ROMs, still were returning valid data. I did know that my PLA should be working because I had replaced it. So I decided to first focus on the video circuit. We knew that we were seeing this weird like colored dots. Like, what is that all about? So let's zoom in on that. This is the video region of the board. Normally this would have been covered with like an RF shield, but none of us have X-ray vision, and I don't have an X-ray display, and I don't think you do either. So like, we have to take that thing off. And we can see that on the circuit board, now you can't see them in this picture, but these chips are all labeled. And so that's really useful for finding out where they exist on the circuit. So U19, this is, I believe, a VIC2 chip. And so its role is to generate video signal, but it needs some help from this little baby chip, U31. U31 is technically a dual voltage controlled oscillator. Its job is to take a clock signal of a certain frequency, and a clock signal is kind of just like a beating drum. I am not beating with any particular rhythm, but use your imagination. And so U31 wants to take this particular clock signal and slow it down and output that slowed down signal on its pin 6. This clock signal is denoted on the schematic. And all the other clock signals that are relevant to this area of the circuit are also noted. And we can use this information to our advantage. Thankfully, I know I'm in a privileged position to be able to afford an oscilloscope, which is a relatively expensive tool. But these days you can actually get them for a whole lot cheaper. And that's a great thing. So I took my oscilloscope and I started probing around. I measured the master clock signal, and that looked fine. And I then measured these pin 6 output on this U31. Pin 6. It's supposed to be 8.1818 megahertz. But it's not. Not on my system. I had this really messy signal. This is not what you want to see. And I knew this chip must be bad. So I bought a replacement. Very fortunate that these things are still for sale. I didn't have to gut one from another system. And so I installed it. Still a black screen, but not a black screen with crazy dots, just a solid black screen. And so that got me thinking, okay, well, the video seems to be good. Let's see if the rest of the system is operating. Now, how can we do that? Well, there are various tools that you can use. Like, you could use a multimeter and try and see, like, okay, what are the various logic levels of these particular pins? But that's not really the right tool for the job. I use this thing called a logic probe. And I'm going to kind of back and forth on my slides here, but just bear with me. This logic probe allows you to really easily determine if a given signal is a logical high or a logical low. And if you put it on something like a RAM chip on like the address lines, you could see that if you're getting alternating between low and high really fast, this tool will make like a little buzzy sound if it's low or high. And it also give you these little indicators. And so if you see activity like on the CPU bus or on like the RAM, you can kind of be certain that the CPU is doing something. And I wasn't seeing that behavior. What I was seeing, though, is that this signal called reset was being held low on my system. Now, what does that mean? What is reset? Well, if you consider a computer that's turned off and then you turn it on, well, how do you guarantee that the various components in the computer are going to be, orchestrated properly? And how can the system initialize? Well, you need to have a ground state. You need to have a known good state to progress from. And so the reset signal is the tool for the job. If you can generate a reset signal when the computer turns on, you say, okay, well, for the first half or 1 second after turning on the machine, send a reset signal out. And all the other chips will get this reset signal, and they'll know to do whatever they need to do internally. And then we can turn off that reset signal and let the magic happen. It kickstarts off all the rest of the booting process. And on my system, this was not happening. Every single chip had the reset signal held low. So they were constantly in this state of trying to reset. And that's no bueno. So if we take a close look at the reset signal, the reset schematic section of the schematic, we can see U20 here, which is this chip on the left. And we can see U8 here, which is this chip on the right. 556 indicates that this is a 556 timer chip. And don't really have time to get too much into those, but these chips can be used for generating all sorts of cool signals. In this case, the configuration of the 556 timer is set up in such a way that after a power is applied, it will generate a quick blip for the reset to occur. And it passes that reset signal over to U8, which is an inverter chip, which kind of takes like a thumbs up and turns into a thumbs down, or a logical high to a logical low. And the specifics of why that works the way it does is, again, out of scope. But basically, this system was not working the way it should. This reset signal was never being turned off. And so I knew by using my logic probe that the 556 end of the system was working. I could see that for a little while, the reset signal was being applied properly and then being turned off. But if you follow the output of the 556 over to the input of the U8 with a logic probe, you can see the signal. And then when you look at the output, you can see the signal. And the output on pin 8 here was just constantly low. And so that was my sign that I need to replace this chip. So I replaced this chip. And again, I'm not going to show the video, but here you can see me right after the computer is turned on. We have a logical low being output. So all the chips in my computer get that little signal. And a brief second later, it goes to high. And that's kind of reversed from what you might think. But if you just give me a little faith, you can know that this fixed the system. Here you can see my extremely messy setup at home. I have a lot of video game consoles. I really like games, play them when I can. And I was so pleased to see this. I did not hear it because, unfortunately, my SID chip is still dead. But everything's working. I wanted to talk a little bit more about preservation and reverse engineering because that's really important to keeping these old systems alive. And I know I'm running a little over time, so I'm just going to whiz through this. There's folks doing really amazing stuff, dissolving chips in acid and imaging them and learning how they work at a super low level. And we're using this knowledge to create modern replacements of those custom chips that I said had no replacements. Well, now we have modern replacements, and that's fantastic. Fortunately for the world at large, you don't even need to have this original hardware anymore. The folks at the Internet Archive are doing a great job archiving the software and providing emulators that you can just run in your browser. A project that I'm really fascinated by is the Mr. FPGA project, which uses really cool technology to re-implement various computers and game systems in hardware, which is really cool. And that's it. Thank you so much. I just want to, take a moment to say thank you to all the essential workers. They've always been essential. It's just they haven't been properly recognized for that. You can find me on Twitter at Claussen. Thank you so much, Bang Bang Con.
Thank you, Matt. So up next is we have a break until 2:30 p.m. Eastern time. That's just about 39 minutes is the length of this break. Before you go, just connect you with some more resources and remind you of what we have going on. Again, later this afternoon, we have an unconferencing session. I'm going to put the things that I share right now, you can find links to them in the announcements channel of the Discord application. So the unconference session, if you want to connect with people about special subjects, interesting subjects, you want to create an unconferencing group, please go check that out. There's a spreadsheet for that. We also have NeighborBot, which you can go in to be matched with other attendees at the conference. We have voice channels in virtual hangout spaces that you can join as open groups. They can come and meet more people as well. We have the Bang Bang Con spreadsheet party, which is just a really fun, creative spreadsheet that you can share and express yourself. We have the job search channel. If you want to find a job, if you want to advertise a job, check that out. And then again, all these things are going to be available in the announcements channel. So you don't have to keep up with everything I just mentioned. But check them out. We'll see you back shortly.
Hi, I hope you had a great break and you're ready for our next session of talks. We're going to have 3 amazing speakers. And the first one is Ben Kuhn. Ben is going to talk about 89 characters of base 11 mobile networking in rural Ethiopia. And before he gets started, I'm just going to tell you a bit more about Ben so you know what he's coming with to this talk. Ben works on helping unbanked people in sub-Saharan Africa send and save money. When he's not bashing his head against obscure network protocols, he enjoys reading, climbing, hiking, making music, contra dancing, trying to improve the world, and various other strange activities. If you want to learn more about Ben, his website is linked in his bio on our website. And now over to you.
Great. Thank you so much. I am really excited to be here. I'm Ben, and I'm going to tell you about a series of increasingly silly things I've done to make an app work when the network is bad. This photo, by the way, is of some of my coworkers climbing on the roof of the house that we all lived in Ethiopia. It was fun. It turns out the roof could barely support our weight. I thought it was kind of an appropriate image. For some context, I work on an app called Wave, which is a mobile money system. So imagine you live in a village in, say, like the Somali region of Ethiopia, and your local bank, local in quotes, is like 3 hours away. So with mobile money, instead of going to like withdraw your money at that bank branch, you could withdraw at you would find a local shopkeeper who's signed up to be a Wave agent. And you can withdraw your cash at that agent, and they would give you their spare cash on hand, and we would reimburse them later. So if you wanted to be really stereotypical startup bro, you could call it Uber for bank tellers. Anyway, we also have this cute penguin mascot. The first problem we ran into while we were trying to build this was that a lot of our biggest users were in really rural areas. The Somali region in general is pretty non-urbanized. So this is my coworker Ahmed taking his motorbike full of cash across a river to reach one of our remotest agents in East Ime. And the other thing about Ethiopia is that there's only a single telecom, Ethiotel, which is a state-owned monopoly. And it's really bad. So in many of these more rural areas, mobile data would be basically totally down for most of the day, and only working in the early morning and late evening. So fortunately, during those other times, there was something else that did still work, which was SMS. So we decided to use that instead. We would take all the network requests that our app was sending, and instead of sending them over mobile data like normal people, we just squeezed them down until they fit inside a text message. So a wrinkle with this is that text messages obviously aren't very big. We wanted to fit everything inside a single message because otherwise piecing them back together would be really hard. And we had to encode the data in the set of 64 characters that are actually safe to be used and interpreted in text messages. So each of those, that means if a character has 64 options, it can represent 6 bits per character. And that meant that with the 151 characters we had, we got about 113 bytes for our messages, which is not great, but you can fit a lot in 113 bytes if you try hard enough. So I hope you remember that log base 2 equation because it will return as the final boss. Anyway, so the other wrinkle after we packed all our messages down was actually building this thing. So at first we thought to ourselves, oh, we can use Twilio like we always do for this kind of thing. Well, it turns out that the whole state-owned monopoly telecom thing also made Ethiotel a pain to integrate with. So as you can see, Twilio does not let you even receive messages from Ethiopia, just at all. Instead of doing that, we had to build our own SMS integration from scratch. So that meant we needed a computer that was connected to Ethiotel's internal network. And that meant it had to be inside the country. And that meant we needed our own data center. For some value of data center. So this building was our actual data center. Our servers are running in a little closet off to the right of the frame here. It ain't much, but it's home. Thankfully, it did have one nice thing, which was a backup generator for the many times that the municipal power went down for 8+ hours at a time. But
Sadly, the backup generator also often broke. And at that point, we would need to fail over to our backup system, which is that our customers would call our employees' personal cell phones, and we would use // commands to enter their transfer details. Okay, so that worked fine for like some value of fine for a while. But soon we started having an even worse problem, which is that like even during normal periods, our agents couldn't do transactions fast enough because they were spending too much time staring at the loading spinner on their phones. Even in the areas with relatively good network, like Gigiga, the capital. So when I tested in Gigiga, I found that pings were taking something like 5 seconds, which is like a normal ping time. But our apps requests were taking more like 30 seconds. And that was confusing to me. We were sending like somewhat more data than just the ping command. But remember, it all fit in a single SMS, so it wasn't that much data. So to explain why this is going on, I need to take a detour to explain how normal mobile apps do network requests. You think of it as using the protocol HTTPS, but that's actually made of a stack of a few different protocols that operate at different layers of abstraction. So the lowest level protocol is called IP for Internet Protocol, and that gives you only a single operation, which is do your best to send this small packet of data to this given address. But the packet is allowed to fail. You can just sort of drop it on the floor if you feel like it. So on top of that, there's built TCP, Transmission Control Protocol, which gives you two things that IP doesn't. One of them is reliability, so you know that the sender received the packet, and the other is unbounded size. So TCP lets you send a potentially infinite stream of data. Then HTTPS runs on top of TCP, but it's actually within that, it's a stack of two other different protocols. So the lower level is TLS, Transport Layer Security, which is like TCP, but the stream is encrypted so that the data is only readable by the intended recipient. And then on top of that is HTTP, good old HTTP, which gives you the, actually lets you say like, get me the document at this URL, and then you got a document. Or if you're a mobile app, you can abuse that to mean things like send a payment, and like the payment worked. Okay, so because these protocols are all stacked on top of each other like this, that introduces quite a bit of overhead. So TCP requires you to send an empty packet back and forth before an empty IP packet, that is, back and forth before you start sending actual data. Then on top of that, TLS adds an additional 2 back and forths to do things like public key exchange and cipher suite negotiation. And so it's not actually until the 4th packet round trip that you can start sending the data that you wanted to send in your HTTP request. And that's why our requests were so slow. If a single packet round trip like ping would take 5 or 10 seconds, then these 3 like round trips that do nothing for us at the beginning of this sequence are adding 15 to 30 seconds of overhead. So can we do better than that? Well, yes, these intermediate protocols are giving us a lot of stuff that we don't need. So in our case, we're talking to a single server that we know ahead of time, and that means we don't need key exchange or cipher suite negotiation. And because we'd already packed our data down to fit inside a single SMS, it also fits inside a single IP packet, so we don't need the stream abstraction that TCP provides us. So in order to slim down our protocol, we ended up building our own based on a different lower level protocol called UDP, which stands for Unreliable Datagram Protocol. So that's a very thin wrapper around IP that doesn't incur any additional round trips. Unfortunately, as the name might suggest, UDP sacrifices one thing that we do need, which is reliable delivery. So UDP packets are allowed to be dropped, just like IP packets. Well, implementing reliable delivery the right way seemed hard. So we took the coward's way out and just sent every packet and response 4 times. And that pretty much worked. Okay, so UDP worked great for us for a while. Until a point later when we started getting taxi drivers to use Wave to accept payments. So these drivers often worked in a downtown area where there were so many people on the network that mobile data was too congested even for UDP to work well. And because the customer was sitting in their car waiting for the payment to finish before they got out, SMS was too slow for this use case. By the way, the taxi product was in Senegal, and that's why there's water in this picture. This is the fish market near where I lived. Okay, so fortunately, we have one more weird protocol up our sleeve, which is USSD, unstructured supplementary data. So USSD is primarily used in developing countries, and it's used for things like topping up your prepaid airtime on your phone. So you would like buy a scratch card at the corner store, and it would have some magic digits that you dial, and then you dial them, it pops up a loading spinner, and eventually you get a text box that's like, you've got airtime. At the protocol level, it works pretty similarly to SMS, but the traffic is prioritized more highly because the customer just paid the telco money, and like the telco probably wants to like receive it. And also they're looking at a loading spinner. So we decided to try sending a request over USSD. So unfortunately, USSD has even worse message size limitations than SMS. It actually goes through the same parts of your phone stack as when you dial a phone number. And believe it or not, phone numbers are limited to a mere 98 characters on the network that we tested, of which 9 were consumed by our prefix. So furthermore, the dial string needs to be numbers. So each number gives you 3.32 bits. It turns out the log-base-2 formula works with fractional bits per character as well. And that works out to about 36 bytes if you do the math. So that's cutting it really close. So I wanted to see if it was possible to use any alphabetic characters instead. I tried the docs for this, but of course, nobody had foreseen possibly wanting to abuse USSD in this way. So I was out of luck. And that meant the next step was source diving. So Android is open source. You can just read most of the source code of the Android operating system on the internet. And that meant this turned out actually to be relatively easy to track. But I'm going to go through it fairly quickly because it's not that exciting. So I'll just like dive through some garbage wrapper layers. And it turns out that, so eventually I found that the operating system was sanitizing any number that was dialed with this is dialable function, which allows digits 0 through 9, the asterisk, the pound sign, the plus sign, and this wild thing, which turns out to be the letter N. So I don't know why. I don't know why N is wild, but it is pretty wild. So where does that leave us? Well, the asterisk and the pound sign have like special USSD meanings to like a piece of middleware. So we couldn't use those. The plus sign didn't work, and none of my coworkers remembers why it didn't work. But the character N works. So we've gotten ourselves one whole extra character, taking us up to 3.45 bits per character and 38 bytes. Woo! So not a huge gain, but worth celebrating. This is us doing a traditional Somali dance. So I thought I'd close by explaining where we ended up with on each of these things. We're not using USSD today because it requires deals with every telecom that you use it with. And some of them run competing mobile money systems. We're not using SMS because in Senegal, internet is like mostly good enough. And that Senegal is where most of our business is today. We do still use UDP. But the next version of HTTP, the normal protocol that everyone uses, contains many similar optimizations to the ones that we made. So we're excited to replace it with something like slightly more normal once that's mature. Yeah, this is a fishing boat doing donuts into the sunset because that's how I felt when I finished this project. Great. All right. Well, thanks for listening. You can find the slides at benkuhn.net/base11 and some links to further reading resources. Thank you so much. It was fun to tell you about this.
Awesome. Thank you, Ben. This was pretty fun. I especially enjoyed all the UDP jokes in Discord, so I can't stop laughing. To give some more time for people to switch channels, I'm going to invite Erdi to hang with me for a bit in the stream.
Hey, what's up?
Hey, how are you doing?
I'm doing well. Yeah. Oh my gosh, the jokes that were flying in the Discord channel. I like how you and I both, when he was like, yeah, we're gonna like send the message 4 times, we both immediately started like repeating the jokes 4 times. Yeah.
Everyone loves UDP. We also love UDP because we're streaming, right?
Yeah. Hey, look at us using UDP right now and not over SMS, fortunately or unfortunately, depending on how you look at it.
I mean, that's an idea for the next BangBangCon. We should just do this over SMS and see how it works.
Yeah, there you go. Alicia, the chat has noticed that there's a cat somewhere. Is that?
Yes, I am sorry. My cat's decided the perfect
No,
time
please.
to meow.
Yeah, if you bring them on stream, I bet everybody would enjoy that.
Give me a second. I'm going to grab one.
Great. I'm not actually. I'm actually in a real estate office because they've got better internet than home. So my cat is not around, unfortunately. So.
Okay. So this is DC. He's the fluffy, beautiful.
Oh my gosh! What a beautiful cat.
Yeah, they both want to go out, so they're very unhappy that I'm at my computer right now.
Look at those whiskers.
DC disappeared because they don't want to be held, so you only get DC for now. Awesome.
Alex Wyckoff asks if that one's called DC. Is your other one named AC?
Yes, both my cats have very great, which was very confusing during Nick's talk yesterday because he kept saying AC and DC, and I kept thinking about my cats. So it was really confusing for my brain.
Amazing. How are we doing? Let's see if our next speaker is around.
Yeah, I think James is ready to come and say hi.
Great.
James's talk, thank you, Artie. James's talk is pre-recorded, so I'm going to give him a moment. Oh, baby! Okay, I'm just going to quickly say a few things about James, and then you can say hi. And I mean, this is amazing. We got babies, we got cats. Who doesn't love remote BangBangCon? So James's talk is about CBS televised computer-generated stories in 1960s and 10 million watched. I am very curious about that. Just let me tell you a bit about James. He's a researcher and practitioner at the intersection of art and computation, and his current focus is on digging up obscure pioneering work in this area with an emphasis from forgotten early examples of story generation and computer poetry. James.
Hi there.
There.
Yeah, no kidding, but I got a baby here. This is Viv. I'm James. We're coming live from Minneapolis. My talk's pre-recorded. It'll play in just a moment, but we wanted to stop by and say hi to everybody and extend a hearty thank you to all of you watching, and especially a thank you to the BangBangCon organizers who've done such a fabulous job with this remote version. So my talk will play in just a moment. I hope you like it. I'll be on Twitter and Discord, and I'm pretty easy to find. Thanks for watching.
Awesome. Thank you for coming to say hi.
My pleasure. Viv's too.
It's 1960, and the MIT Centennial is just around the corner. CBS notices this and decides to celebrate the occasion. They'll make a television program. They'll call it Tomorrow. It will be about the future that MIT scientists are working to create. This is Douglas T. Ross, professor at MIT. He's busy coining phrases like computer-aided design. And this is Thomas H. Wolfe, television producer at CBS. He's worked on shows like See It Now with Ed Murrow, but now he's writing and producing Tomorrow. Wolfe and Ross get lunch in New York. They're discussing whether computer-aided design would make for compelling television. Ross fears that it won't. It's too esoteric, he tells Wolfe. The mood goes dour. The lunch is almost over. But then Wolfe pops a wild question. Could a computer write a Western, he asks. The plots are so formulaic, he says. Could a computer write a Western? Ross thinks about this for the rest of the lunch and indeed for the rest of the month before finally writing back later with an answer. Yes, he says, but only if it's a pantomime, no dialogue. Wolfe remains enthused, and it would appear that a peculiar collaboration between CBS and MIT is underway. But then, Claude Shannon, for reasons I have not been able to determine, attempts to convince Wolfe not to go down this path. But ultimately, he is unsuccessful because this is CBS televised computer-generated stories in 1960 and 10 million watched. I'm James Ryan. This work was done in collaboration with Gillian Smith, with special assistance from Don Knuth, Chris Garcia, the Computer History Museum, and MIT Archives and Special Collections. Special thanks also to Mark Sample and the Bang Bang Con 2020 organizers. Shout out to Liza Daly. No one had ever done anything quite like this before. In 1952, Christopher Strachey produced computer-generated love letters, and in 1959, Theo Lutz produced computer poetry in German. But this would be the most ambitious undertaking in computational media to this time, and Ross had to invent everything from scratch. His early sketches are remarkably well formed. Each story will take place in a hideout and center on a shootout between a robber and a sheriff. Characters will move about the world along 6 places of action: the corner, the table, the window, the door, the area outside the door, the area outside the window. Action will center on props: money bags, a bottle of whiskey, a glass, and of course, the guns. Each prop affords certain actions. You can pick up, put down, count, or gloat over the money. You can pick up, put down, pour, or drink from the bottle and glass. You can do gun things with the guns. You can do other things no matter what you're holding. This is Harrison R. Morse, aka DIT, graduate student at MIT. He's going to lead programming on this effort using the TXO computer. This is the legendary machine on which the original hackers, the Tech Model Railroad Club, are learning to compute at night. Morse is working in machine language, much of it macro generated, and he's on a TV production schedule. He must deliver generated screenplays to CBS in 6 weeks, or the network will go ballistic. Source code does not survive for this program, but flowcharts do. Here's a segment that I've reconstructed for illustration here. It defines how the sheriff will act in the world at a high level. First, he enters the scene, then he goes to the window. Next, he calls the look routine, which has its own segment in the flowcharts. As a result of look, he may spot the robber, and the robber may spot him. From here, we proceed to what Morse calls a switch. This is a probabilistic branching point in the logic. It's what allows the program to produce unique stories each time it's run. To decide which way to branch, the program consults a scoring mechanism for that switch. This takes each of the possible branches and scores them according to the state that the world is in. Authors define these scoring mechanisms. As an example for this switch, if the sheriff has spotted the robber but not vice versa, the advance and other branches will be about 10 times more likely to be taken than the wait branch. Let's say we go this way. Now we've reached a different branch, but this time it's deterministic, based simply on what's in the robber's right hand. Let's say he's holding a gun, which means we proceed to another switch, which will have its own scoring mechanism. From here, let's say we go this way. Now we've reached the shoot routine, which will have its own segment in the flowchart. There's 3 of these flowchart leaves, which gives a sense of the size of the program, which Morse and Ross named Saga 2. Now, one peculiar thing about Saga 2 is the level of detail with which certain actions are modeled. All of the logic you see here is simply so that a character can empty his hand of an object. Now, one cool thing about Saga 2 is the authoring interface that Morse made, utilizing the Flexowriter online console at the TXO. In an authoring mode, whenever a switch is reached, control of the program is temporarily yielded to a human author sitting at the Flexowriter console. By typing into the console, the author can modulate any scoring mechanism for any switch, thereby changing how the stories look in real time. Saga 2 is specifically a script generating program. As it's being executed, the Flexowriter prints out, line by line, a generated script. Here's an excerpt from a script that I found at the Computer History Museum. Now, Morse didn't have computer memory or time to devote to a natural language generation module. So he had to rely on a clever hack for actually producing the language. Here's how it worked. At any given time step t, the story world is in some state. Then the next action will occur, sending the world into its next state. Anytime this happens, Saga 2 checks for the delta between these, and this delta is rendered in natural language as one line of script using simple rules. Right on time, 6 weeks later, Morse and Ross delivered 9 of these computer-generated scripts to CBS, along with Ross's sketches. CBS then built a physical set from the sketches and cast the talent. In the role of Sheriff, Haywood Hale Brown, future sportscaster, and Robber, played by Jack Gilford, future Oscar nominee. Gilford is particularly spectacular. Recall the level of detail with which object handling is modeled in Saga 2, and now watch Gilford's hands as he performs the generated lines, the bottom right. Notice the passing from left hand to right and back. Now, one interesting thing about Saga 2 is that the more characters drink, the more erratic their behavior becomes. This is called the inebriation factor, and it affects nearly every scoring mechanism, producing interesting emergent narrative in some of the scripts. CBS produced 3 of the generated playlets, 2 of which are especially remarkable. In the second, the robber hits the sheriff, killing him before making off with the cash. To my knowledge, this is the first time in television history that a villain was victorious. This is because Wolf did not believe that a machine could be held to the strictures of the Hays Commission or FCC regulations on what could be written for television. The third playlet is glitch art. CBS enacted a buggy run of Saga 2 to humorous effect. In 1960, there were 3 television stations in the US. That Night Tomorrow aired on CBS against Peter Loves Mary and Naked City. It finished second in the ratings, with Nielsen estimating 7.7 million audience households, which allows us to safely assume that these computer-generated stories were watched by at least 10 million. The next day, newspapers ran sensationalistic headlines and an amazing illustration. The reviews were generally favorable, but one contingent was livid. At the end of the program, Thomas H. Wolfe is naturally given writing credit. But additionally, so is the MIT computer TXO. This incensed the Writers Guild of America, who demanded that CBS remove the computer's credit should the episode ever be re-aired. To my knowledge, it never aired again. This was CBS televised computer-generated stories in 1960 and 10 million watched. I'm James Ryan. You can find more of my historical work on Twitter at XFOML, and you can watch the generated playlets at tinyurl.com/saga-2. Thank you so much for watching.
I have muted myself. Thank you, James. That was awesome. I am also super impressed with your radio voice. This felt like a real, television or radio stream. So before we start on the next talk, I'm going to invite one other organizer who wants to hang with me, Ahmed Erti.
Hey, how's it going?
Awesome. Hi. I have managed to get my second cat in, so I'm going to show you AC this time.
Oh, yeah. Ahmed, come hang out with us.
This is AC. He's very unhappy because I gave them a lot of treats and now I'm no longer giving them treats. So, Bang Bang Khan is spoiling them.
Did you say tweets or treats?
Treats. Yes, these ones. If you see
I'll
my
tweet
mom
about your cat,
calling at
is what
any
I'm saying.
point, that's probably them attacking my desk to get the treats. So, sorry about that.
Amazing. I just imagine you tweeting about your cats also, which would be great. So.
Yeah, we'll make that happen. So I wanted to just point that this experience, this streaming experience, has been super seamless for me. Like, I'm just joining a stream and it works. And I know you know a lot more about the magic that is happening, and Cindy just making it work in the background. So it'd be great if you could talk about it a bit.
Yeah. So We were going to do our own custom stuff. I'll still write that up just so other people can learn from our mistakes and maybe help us debug. But we're using this new thing called StreamYard. Cindy, who runs Confreaks, pointed it out to us and just said, "Hey, this is something that we're using for some other conferences." And I said, "All right, great, let's do it." And then it was so seamless. And we did AV checks with every single speaker before this, so that was some of that like behind the scenes work. That took up a lot of time this week, but I think it was worth it because we've been able to get everybody in here so seamlessly. It turns out that OS X will make you restart your Chrome instance if you haven't shared your screen before, so that was exciting. A lot of sitting around and waiting for Chrome to restart, but it was good. That's the kind of thing I'm really glad we figured out then, instead of trying to do it live on air and having to like tell every speaker to restart Chrome.
Yeah, that's awesome. I know there's a lot of work going on there. I was just observing on the side. If you're curious, I know that on Discord and on Twitter, Cindy is there to answer any questions. And as I said, I'm just coming here and turning on my camera. That's about how much I'm doing for the stream. So thank you, Cindy, for making it work. It's amazing.
Shout out to Cindy. Shout out to the people who implemented WebRTC. It turns out when you if anyone wants to give a talk about WebRTC using WebRTC, I would love that. Submit it for. Well, I don't know. We'll see. Hopefully, Bang Bang Con 2021 will be in person, but we don't know. So we'd still love to hear about it either way.
Yes. Awesome. Thanks for hanging with me. I think Matthew is ready. So Matthew's talk is also pre-recorded, but he just wanted to come in and say hi to everyone. Hey, Matthew.
Hey, are you hearing me?
Yes.
Excellent. So as you might guess, I've been having some connection problems, so I'm very glad I pre-recorded this. I don't have any babies or cats to show you. I apologize. But thank you for letting me share a weird recent obsession of mine.
Yeah, awesome. So let me just read the title and read a bit about you so people know who is going to present for them. Matthew's talk is about programming from an alternate timeline. Sounds amazing. Matthew is a Seattle area industrial artist with a particular interest in kinetic sculpture of all scales. And the history of technology provides the inspiration format of his work, as well as exploring the beauty of mechanical design. I hope you enjoyed this talk, and thanks for jumping in to say hi.
Thanks.
Hey everyone, this is a talk about programming from an alternate timeline. So first, some background. I'm Matt Dockery, also known as Fish. In my day job, I work on software that controls industrial measuring systems. Otherwise, I'm a metal worker and a kinetic sculptor who's been doing a lot of public art installations over the last few years. But computers were my first passion, and I certainly still love making them do weird things. So I've recently been reading a lot of primary documents in the history of math. And one of the things this quickly teaches you is that we're very lucky to have notational systems as standardized as they are today. As a programmer, I was particularly interested in tracing the development of logical notation. It's Boolean logic, so maybe it goes all the way back to George Boole himself? Not really. The notation in his works is explicitly algebraic. He's really developing more of a concept of set theory and probability than mathematical logic. He uses multiplication to mean both logical and set intersection. Addition is set union, and so on. One of the first things he derives from this is his fundamental law of thought. If x and y are identical, then x times y equals x, which is the same thing as x squared equals x. The only solutions to this are x equal 1 and x equals 0, which he interprets as everything and nothing. I can't say I'm quite sure I agree with that proof. But given how 0 equals false and 1 equals true dominates our lives today, he does seem to have stumbled into something important. Skipping over the rest of the 19th century for a moment, the next work which dominates the logical landscape is Russell and Whitehead's Principia Mathematica. This is an infamously complex and lengthy work, more influential in concept than in practice. But it's also important for helping solidify notation. It rejects parentheses for grouping, however, instead using a tiered system of dots. But a lot happened between those two, including a glorious system that is almost entirely forgotten today. In 1879, Gottlob Frege published his Begriffsschrift, or concept writing. This was one of the first stabs at trying to derive basic mathematical concepts from logic, and in that sense it was immensely influential. It was also an almost complete break from any notational system that came before or after it. Often described as a flowchart or being two-dimensional, it really is worth studying even if you have no interest in logicism or mathematical philosophy. He describes judgments, which are either affirmed or denied. If a statement is a judgment, it is preceded by this thick vertical line, which shows it to be something known to be affirmed. Without this stroke, it is a mere combination of ideas to be considered. Everything connected to the horizontal line is included as part of this judgment. Expressions can be negated using this symbol, the only part of his system that was adopted elsewhere. He also has letters which represent a value or a judgment. They're basic variables, except they're not variable. Okay, now into the fun stuff. This is conditionality. To define it, he sets out a truth table and says this symbol stands for the judgment that a third of these possibilities does not take place, but one of the other three does. While not otherwise naming it as such, he's describing the logical operator of implication here. While this is sometimes written as if B then A, it's important to note that it is not the same thing as an if statement. Implication is only false if B is true but A is not. If B is false, the truth value of the operation is always true. That is, a false statement logically implies everything. Consider the statement, if it is raining, then I am wet. It only deals with the situation where it is raining, in which case I must be wet for the statement to be true. If it isn't raining, however, it has nothing to say. Maybe I'm dry, and maybe someone just dumped a bucket over my head. In either case, the original statement is still true. I find it best to think of implication in modern terms of not B or A to keep from getting confused. Like all early logicians, this was his only logical operator beyond simple negation. And that works fine. You can formulate any statement you want using just those two. But it does seem very clumsy to the modern reader. This is one of the things that struck me most deeply learning the early history. Good old and or aren't that old. Mathematical logic developed out of philosophical logic, and that meant Aristotelian syllogisms. For a long time, all they were trying to do was formulate a more rigorous version of all men are mortal, Socrates is a man, therefore Socrates is mortal. It wasn't until mathematical logic was explored for its own sake that the greater expressiveness of and or became to be appreciated. There was also the generality. In Frege's words, this stands for the judgment that, whatever we may take for its argument, the function is a fact. This works exactly like the universal quantifier or turned A notation of predicate calculus. They're both nothing more than a formal way to write Aristotle's all men are mortal. There isn't, as you might be expecting, an existential quantifier, such as the backward E of predicate calculus. This isn't strictly needed, as it can be phrased in terms Frege has already defined. To say, there is an immortal frog is the same as saying, it is not true that for all frogs F is not immortal. This lack was common in Frege's era. The existential quantifier was another bit of syntactic sugar that took a while to be considered as a basic operator in its own right. The Begriff shift goes on to develop other terminology in terms of the above, but those are the basics. And reading through it, while struggling through the interpretation, I couldn't help but feel sad that this amazing notation had never been picked up by other mathematicians. What if Russell and or Whitehead had used it to write the Principia? What if Turing had used it when outlining the next 50 years of computer science? What would programming look like in that world? I decided I had to find out. The end result is Gottlob, my esoteric programming language. It is implemented in JavaScript, so it can be run in any browser. This was kind of a cheat, since it meant I didn't have to write a lexer parser. And I really like writing lexer parsers. But it was always going to need a custom editor for the notation, so I figured it was best to keep it as accessible for people as possible. Now, just like there isn't a one-to-one mapping between mathematical notation and real programming languages, Frege's system had to be adapted to turn it into something that can do things instead of just proving them. I made the letters be actually variable, for instance. Following his example, these are all single characters typeset in Fraktur. They must be declared using the judgment stroke. Also following his example, functions are typically named as Greek letters, but this isn't enforced. The namespace of Greek letters is limited enough that all the built-in utility functions are given normal English names. Conditionalities remained more or less the same, just interpreted in a functional context. B is evaluated, and only if it is affirmed is A evaluated. The entire thing remains a logical operator, however, whose judgment is always affirmed unless B is affirmed and A is denied. Generalities were obviously destined to become a loop operator. However, they couldn't actually be universal quantifiers. Forcing for statements to loop over all the integers would present both implementation and application difficulties. In Gottlob, the quantifier statement uses the pre-existing value of A and loops over every component if it's an array, or from 1 up to and including its value if it's an integer. Like conditionalities, the generality remains a logical operator. Its judgment is affirmed if and only if phi of A is affirmed for each and every value of A. I also added a matrix generality, which instead of returning a judgment, returns an array made up of the return value of every iteration. This was a complete fabrication on my part, but it proved useful and seemed true to the spirit of the alternate timeline I was trying to channel. The rest is more or less a standard programming language that uses standard mathematical notation wherever possible. The editor allows direct editing of any part of the program, with statements being entered either from the menu on the left or via keyboard shortcuts. Basic arithmetical operations are entered as JavaScript, just to keep it simple. So what can you do with it? Here is a simple Siva-Varathanese prime number function. The original value is saved in the letter C, which a generality then loops over. So for every number less than or equal to A, the conditionalities must be affirmed if they are 1 or A itself, as those branches evaluate to denied, and conditionalities are always affirmed if that branch is denied. So that just leaves the check to see if the value C does not divide evenly into A. If it doesn't for all values of C, then A must be a prime. This is the classic Gregorian leap year calculator. A year is a leap year if it is divisible by 4, unless it is divisible by 100, unless it is also divisible by 400. This is compactly phrased in Gottlob as such, which makes sense if you pick it apart. The inner conditionality will only be denied in the situation when the year is divisible by 4, but not by 100. Thus, the outer conditionality will be denied when the year is not divisible by 4, and also when divisible by 100, but not by 400. So what did I learn from all this? While I appreciate the link between classical logic and programming languages a lot more now, like a lot of science and math, that all tends to get taught in very ahistorical ways, and I wish I'd learned about that connection earlier. And I definitely appreciate modern notation a lot more now, particularly the dominance of and or over implies. I'm sure I'd get more comfortable with it if I used it all the time, but even after playing around all this time, I do still find it fairly unintuitive. Simplifications like that are an unsung glory of mathematical formalization. It's easy to dismiss that as an academic thing, but writing things down in abstract notation can lead you to important discoveries. People had been working with classical syllogisms for literally 2,000 years, and they never noticed how much simpler it would be with and or. But within decades of Boole's first attempt, those started to emerge. So abstract notation can free you from assumptions you didn't even know you had. Thank you.
Thank you, Matthew. That was super clear and super fun. So this is the last talk for this session. And the next session, we have an unconference. So if you're on Discord, there is a spreadsheet. You can sign up for rooms. You can see what topics are there. If you're not up for unconferencing, you can do any of the other fun things we have for you. You can use the neighborhood bot. You can just hang out in the virtual space, or you can just take a break and get some energy for our last session. So for those of you who want to take a break or are just watching us stream on YouTube, our last session will start at 4 p.m. Eastern, and we can't wait to see you there.
Hello. It's 4 o'clock Eastern time, so we're going to continue on with our last section of talks. We have 3 amazing talks coming up for you right now, and then maybe a secret one afterwards that you'll have to stick around to see. Our 3 talks that are happening, I'm pulling them up, are last but not least, and there's a couple of these that I'm particularly looking forward to. I love mixing poetry and programming. So this first one is for me particularly interesting. Andrew, can we put Andrew in here? Hello.
Hello.
Thank you for joining us. I will introduce you real quick and then get out of your way. And it would be really easy to introduce you if I had the right webpage. Andrew Yoon is making poems that change, live coding noise, playing melodica, growing the art journal nothingtosay.org, and advocating for copyright abolition. He can be found online at andrewyoon.art. Take it away.
All right. Well, hi, I'm Andrew, and I'm really indecisive. Normally that's okay, since it just affects me and my personal development and my ability to watch movies. But unfortunately, I'm also a writer. And the thing about writing is that you're always making decisions. Every word you choose, every line break you insert, every little bit of punctuation, it's just countless decisions. And through all of these decisions, there's a lot of pressure to make the right one. Every time you pick a word, there's all of these wrong choices to make, and there's one right choice to make, and you're expected to find the right choice. And I don't necessarily believe that right choice exists. And it, to be honest, makes me uncomfortable having to choose a word, because I feel guilty leaving out all the other words, because they were perfectly fine. They didn't do anything wrong. They deserve to have their time of day. So I want to find a way to not exclude them. So I made a thing. This thing is called BML, or the Blur Markup Language. It's a programming language for writing text that changes. Rather than writing exactly what you want people to read, you express the possibilities, and these are then chosen for you on demand. So here we have a basic summary of what the language is, and a bunch of different ways to write it out. Like we can spell BML lowercase, as I prefer, or uppercase, or you can fully spell out the acronym, and then we can describe it as maybe it's lightweight or hacky, all these different things that can happen. And you can see 5 different ways that it's been realized below. And hopefully you can kind of see that all of the details change, and the number of permutations that could occur here is really quite large. But at the same time, the shape of it, the meaning behind the text, somehow stays the same. So let's talk about the language a little bit. Inline choices, we have these, and you've already seen these. So this is just listing a bunch of different things that can happen, and we can assign different weights to them. So in this case, we're doing A, B, and C. A is going to happen 50% of the time, B is going to happen 30% of the time, and then C is going to take up whatever remaining probability we have. And below in all these examples, you kind of see a rendition of this code a couple of different times. So we have C, A, B. We can also apply rules over larger swaths of text. So in this case, we're taking the word and we're looking for it everywhere. And every time we encounter that, we might use the word and, or we might insert an ampersand instead. We can also do more complicated things like running arbitrary JavaScript. In this case, we're using a regular expression matcher that's just looking for the first letter of words. And it's going to then capitalize that. And we've run this a few times over this really lovely quote by John Cage. I have nothing to say, and I'm saying it, and that is poetry as I need it. And the different capitalizations that occur kind of apply different weights into the text and shape the sentence in different ways and highlight different thoughts. And I think that's really interesting. It can do a bunch of other things. So we have a standard library of common functions. Standard library, it's actually like 3 functions, but they're useful things to have around that are then available inside the eval API. We can call inline function calls. We can do markdown rendering. We can escape blocks and have literal text blocks. And we can also reproducibly generate the same text by pinning a seed. And it also works in a browser, so you can put it in your websites. In terms of how it's actually built, it's just a bunch of bad JavaScript and truly evil uses of the eval command, and we're not going to talk about it. So some of the things that I've done with BML, this is an excerpt from the source of a dynamic poem I made, and you can see the number of chance elements and permutations starts to become very high very quickly. But at the same time, again, the larger structural ideas can retain their shape, if that's something that you want. And you can see here's a rendition of that poem in full. I'm not going to pause and dwell on it too much, but you can go back if you like and check it out more. This was installed, well, so this is a contraption I made that I endearingly call the Poetron. It's just a box with a receipt printer and a big glowing button. And when you press the button, it generates a poem using BML and prints it on a receipt for you to take home. I installed this in a gallery, CJ1 gallery in New York City in February, I think. And I think visitors had a lot of fun coming by and pressing the button and printing out versions of that poem we were just looking at and taking it home with them. Also, because it's embeddable on websites, I've made blog posts with this and kind of covertly just published them as if they were well-behaved blogs. But in fact, the text does change every time you refresh the page. And really excitingly, I'll be publishing a full-length book of chance poetry with Ost Press in 2021. We'll be publishing one or a couple physical versions of the book while simultaneously publishing it online, where visitors will be able to explore the gazillion different versions of the poems, and they'll be able to kind of discover different versions of the poems and share them with other people. It's going to be a lot of fun. I'm super excited about this. And just for kicks, this presentation also is generated with BML. And as I speak right now, this is the first time I'm seeing this presentation. And I can show you the sorts here. So like one fun thing we're doing is every time we have an exclamation mark, we repeat it some arbitrary number of times. And there's a bunch of just like stuff that's going on here. So more seriously, why is this interesting? I think dynamic text makes the reading experience more intimate and invites a more critical mode of reading. Maybe by reading several versions of the same text, the reader can come closer to the underlying thoughts of the writer. At the same time, it's kind of a trope that writing is already a process of self-discovery. But as a writer interacting with this medium, I found a surprising and rewarding feedback loop between me and the text that comes out of this. Seeing my words scrambled and rearranged and really out of my hands in some sense has radically changed the way that I write and think about text and my own style. And like I mentioned at the beginning here, I think this calls into question the idea of the author and the assumption that there exists a correct text, that there exists a best way to make a thing. And at the same time that it challenges authorship, I think it challenges ownership. A question I'd like to leave you all with here today is, what does it mean to own a text that nobody wrote? Thank you so much. You can find out more about this language at bmllang.org. That's bml-lang.org. You can find me online at andrewyoon.art, and I'd love to hear your thoughts. Thank you.
Wow. I just want to point out, because I missed it for a moment, that those slides were generated using Poetron or BML, I should say. I guess Poetron is the physical manifestation. That's amazing. Alicia, do you want to join me? I think we were saying that you would pop in, or Julia. We just, if any organizers in here want to join, feel free.
Yeah.
Yeah.
I want to shout out the things I love, because this is all about that. So did you see the Animal Crossing t-shirt somebody designed?
I did see, and you posted it on Twitter, I think.
Yes, so if you want an Animal Crossing t-shirt from this BangBangCon, our colors today are wrong. The orange one is the right one for this year, so grab it.
Yeah, I'm wearing double BangBangCon shirts.
Oh, you super bang bang bang
Bang,
bang
bang, bang, yeah.
Repeat it
And,
4 times.
Yeah, it's the same sweater as yesterday, but it turns out at a virtual conference, people don't get as mad about you like not changing your clothes.
Yeah.
So
That makes sense.
wait, don't tell anyone. Oh my gosh. Yeah, if you for anyone just watching the stream and not in Discord, you should have seen the reactions fly by when it was revealed that that talk was being like generated using BML in real time. It was like the crowd went wild, as much as that can happen at a virtual con.
Yeah, I think the thing I love the most about this is that people are self-organizing things. So we're just sitting here and we are enjoying ourselves and doing the stuff we planned, and everyone else is just doing a ton of other things. And it's just so amazing that the community is growing.
Yeah. Yeah. Somebody embedded the spreadsheet party webpage inside itself. So like they were writing HTML in the spreadsheet and then using a glitch app to take the HTML in the spreadsheet and then like display a web page, but then there was an iframe of the spreadsheet in that web page, so you could like edit the spreadsheet and then like the page would just change on refresh. If somebody gets that working in real time, I'll be amazed. But
I think that's amazing. Also, my brain by this point is just so overwhelmed with everything. I'll have to revisit it next week.
Yeah. It's like this is what happens when you get a bunch of just like really fun-loving programmers all together in the same place, and everyone's extremely online all the time. So, yeah. While we're shouting things out that we love, shout out to my uncle Stan who's watching this. Shout out to the other organizers. Shout out to Cindy and Mirabai again and always. Ahmed, who are you shouting out to?
Shout out to our attendees who still, made it strong.
Yeah. Definitely. Okay. All right. Let's sorry. All right. Is M online?
Awesome.
Yes. Hello. Welcome.
Hey everyone.
Hey. You get 3 people introducing you, I guess.
Exciting.
Oh, now we're down to 2. Oh, now it's just me. Okay. Yeah. Thanks for joining us. I know yours is pre-recorded, but I figured we'd let you just come in here and say a few words. I'll give your little intro though. Em is a Toronto-based artist, engineer, and game designer. Most of her work focuses on using non-traditional interfaces to reframe everyday objects as spaces and playful experiences, and to inspire people to become self-motivated learners. Very cool. Yeah, tell us a little bit about this project and yourself, and then we'll roll the video.
Yeah, so you will hear all about it, but I'm going to be talking about sort of more the design side of game design and how can you use tools like physical hardware, MIDI controllers to make game design better and make yourself a better game designer. And I'm very, very glad I pre-recorded it, because I don't know about all of you, but my brain is mush after 2 days of super interesting, amazing, inspiring talks.
All right. Thank you so much.
Yeah. Enjoy. Hey everybody, how's it going? Hope you're all doing great today. So my name is Amelia. I use she, her, they, them pronouns, and I work for Microsoft as a cloud advocate focused on games and spatial computing. But I'm actually here to talk about what I was doing before Microsoft, which was working on a new games hardware platform where we were trying to figure out, we built this new hardware with our own hands. We don't quite know what games work for it yet. So we were spending a lot of time building a prototype or 2 a week to explore different interfaces and see what was fun, what wasn't fun, what we could conceivably actually commercialize. And in doing this, we ran into a really classic game design problem, which is if you have a prototype and it is fun and it is working, that is immediately obvious within 30 seconds of playing it often. But if it's not quite working, it's really hard to figure out if it's because it is not good and you need to leave the prototype alone, or if it's because you just didn't spend enough time polishing it and getting it to that point where you could see how good it was. This is where, like, a lot of types of games, you can usually prototype them with paper components. Even if it's a digital game, you can use cards and dice and paper things. But because we were specifically working on these twitchy action games and exploring like novel hardware interfaces and thinking about like how do you tactily interface with the game, that put us in the realm of what game designers call game feel. The sort of art of tuning, you know, what is this moment-to-moment enjoyment of interacting with this digital system? In a 10-minute talk, I don't really have a lot of time to get into what game feel is or how you deal with it. Here are a bunch of references you can look up. I particularly recommend Ayla's talk from last year's Bang Bang Con, because Bang Bang Con is awesome and Ayla's awesome and her talk was awesome. But long story short, that meant we couldn't just reduce the scope of our prototypes by making them lower fidelity. We actually needed to figure out, well, how can we polish them more quickly and make game design happen faster? And so the way we cut through that Gordian knot, as you might be able to guess from the title of the talk in the first slide, was with MIDI controllers. So this here is a Korg Nano Control 2. Costs about $50 online. Bunch of knobs and sliders, connects to your computer by USB, and you can control them use them to control MIDI interfaces. So we would take our games that were written in Unity and wire up all of our physics constants and all these other magic numbers that we needed to tune to knobs and sliders on this MIDI controller. So what did this actually get us? A whole bunch of things. The first is making it so we could much more effectively tone in on proper values. So if you think about the naive way you do something like this, you would have a value in your code or maybe like a config file. You would set it to a value. You would run your game, play it for a bit, go back, make some changes, play it again. That's really, really slow. Unity is a little better because it has the sort of visual inspector window, so you can change the value while you're playing, but you're still fundamentally in this state of bouncing between playing and editing. Whereas when we have this actual MIDI controller where you can tune the values with your hand, it can become much more immediate. And actually, in many cases, depending on the game and what we were doing, like we would find we could be playing the game with one hand while tuning it with the other, which gets you immediately into this flow state of honing in on what the right values are and what feels right. It also helped a lot when we got to much more complex situations involving interdependent variables. So we spent a bunch of time on this prototype that was a like cartoony kart racer, kind of like Mario Kart. And for that, we were tuning values like acceleration and max speed, not velocity, and your turn radius. And while each individual value is really important, what's a lot more important is the relationship between the two. And that's really hard to model when you're changing one value at a time. We played around a little bit with, maybe instead of tuning the acceleration or the max speed, you're tuning a variable that represents the ratio between them. But that's way above my pay grade to deal with. And instead, it was much easier to say, hey, look, we have this physical thing that has 3 different sliders that I can control all 3 of them with my fingers at the same time. What if I could do that? And then very, very quickly and much more like intuitively suss out like what is the actual relationship between these variables. So that was awesome. It's also really fun. It makes you feel like this DJ code wizard while you're doing it. I love my collaborator used to make all of these sort of proper mise en place before starting a tuning session where they would write out, what is each variable they're tuning and how does it relate to the physical board. And I think this is not just frivolous. I think this actually really, really matters because game design is a creative art and something that can get you into this playful state where you're willing to explore and try new things is actually really, really important to doing good work. But also on a more numerical level, it actually did concretely help because humans have a lot of really bad cognitive biases around numbers. And so it's really unlikely that the proper value for like friction of an object is going to be a nice, beautiful integer or like goes 1 or 2 places in the decimals. But if you're just typing numbers into your IDE, you're going to be biased against using those. Where if you have this nice analog interface, you're going to hone in on what actually feels right rather than what looks right in the text editor. Worth calling out, though, that this is all a bit of a hack. Some of you may be familiar with Brett Victor's work. This is an example from his talk, Inventing on Principle, where he hypothesizes this sort of Super Mario Brothers style 2D platformer and uses this sort of IDE he has built or hypothesized that as you change like your Y jump velocity, you can see it happen on screen as you sort of abstracted away the variable of time. And so ideally, this is the sort of stuff we would be dealing with. Like the fact that you can use design tools to sort of so cleanly cut through complexity and just take your entire possibility space and lay it bare, that's really, really cool. And what I would love to see game design tools and other design tools go. But until we reach that point, a MIDI controller is like $50 and does the job pretty well. So concretely, what did I actually do? So the dirty secret that I learned as I started looking into this is game designers have been using MIDI controllers forever. They just don't talk about it. It's not like they're afraid to let their secret out. They just don't blog about it. They don't give talks about it. It's just not part of the culture. So the only thing I could really find was this talk that blog post that William Scheer posted in 2015 when he was working on his beautiful game Manifold Garden about how we used a Nano Control 2 to do that. So I basically took his work, took sort of his design ideas and formalized them into this Unity library where if you have a Nano Control 2 and your game is in Unity, you just drop this into your Unity project and it gives you a lovely UI to set things up. Saying that a piece of tech just works is really dangerous, I'm aware, so I'm going to attempt to give you a live demo. I couldn't easily set up the custom hardware we were working on. It's a major pain. So this is just a very simple Flappy Bird demo. I can click the mouse and you flap. Exciting. But if I go to the MIDI controller mapping window that I built, you can see here's a Nano Control 2. They also make it in black, so we have a dark mode. Each of the knobs and sliders has a space where you can add mappings. So this one, we already have a mapping in place to the bird game object, which is the player's bird in the scene. Unity uses what's called an entity component model. So each game object has a bunch of components attached to it that each control behavior for like rendering the 2D sprite, for doing rigid body physics, for doing collision detection, and the bird is our custom component that handles flapping. And from there, this dropdown is dynamically going into that bird component and finding any value that we could conceivably control with the controller. So in this case, just up 4 is how much you jump. The current value in the game is 100. Range is just when the knob is at 0, that value is 0. When it's all the way at the top, it's going to be this value. So if the slider is up at full, it's going to be 1,000. So the value for the bird is going to be 1,100 instead of 100. So with that set, if we then go to play the game and I grab my MIDI controller, oops. So I'm playing as normal, but then as I turn this knob, whoops, maybe our jump's a little bit too high, but it works. So I don't have a lot of time, but I do want to talk about one design decision of all of them that is really, really important, which is these drop downs to show you the different components. I can also show it to you in the side here. You can access it this way. So when I built this, my intention was, great, the amount of time I'm going to spend metaprogramming, grabbing all the components and then grabbing all of the editable properties, that's going to be less engineering time than I will probably lose to typos if these are just empty boxes you can type in, which I think is true. But also, this turned out to be a way more important design decision, because now that this is, like, if this was 2 empty text boxes, this would be a very, like, purpose-built tool that I would come to and I would say, this is what I want to tune. I care about these variables. I'm going to do that, and then I'm going to leave. Whereas now, this is now a tool for exploration, where I can look around and say, well, what things can I actually change? And this now becomes not just a tool to allow me to do things more effectively, but again, it puts me in the space for play where I can explore the possibility space and see what I can do. And this is going to help me be creative in a way that the tool otherwise wouldn't have. Like, what happens if I play around with the angular velocity of the bird? And so I think that is actually really important. When you think about making tools for design, for game design, for engineering, usually we're hyper-focused on augmenting human productivity and making things and tools that let us do tasks and jobs faster. Whereas, again, game design is a creative practice. I'm much more interested in thinking about how to augment human creativity and how can I build this tool to enable me to come up with game designs and make decisions that I otherwise wouldn't have even considered. Or to put it one more way, pianos and hammers are both really effective tools if you're a composer or a building contractor. But there are a lot of hammers in the world and not enough pianos. So if you're someone building design tools, you should make more pianos. Thanks a lot.
Amazing. Thank you, Em. Thank you for that talk. What a super neat idea. Build more pianos. Our final speaker of Bang Bang Con, except for the secret talk, is Joshua Wise, who is actually one of our Bang Bang Con West organizers and a member of the Exclamation Foundation board, which maybe the secret talk will cover. Oh, wow, I love that getup. That is I love the headlamp.
Yeah, well, we'll see where the headlamp comes from in just a moment.
Okay, excellent. I'm too excited to delay any longer, but I am going to read your little intro sentence so that everyone knows who you are. Joshua blows up electronics less frequently, but not infrequently, when he does work for his clients, though they would generally prefer him to blow up nothing at all. He is thankful that they, too, understand that blowing things up is an important part of the R&D process. Take it away.
Thanks, Ernie. All right. Okay, so what I'm here to talk about, yes, you notice the headlamp on my head, and I'll be doing some live theater here. So this is kind of the demos could go well or they could go completely terribly, and we'll find out, I guess. So I'm coming with some very exciting news. In this wonderful year 2020, the era of the internet, the year of Linux on the desktop, it's so much easier to screw up than it has ever been before. You can screw up in so many more ways than you ever thought were possible, and you can make even bigger screw ups too. This is really good news. No, I'm serious. This is really good news. And over the next 10 minutes, I'm going to tell you about one of my new favorite ways to screw up. But before we get there, we make tiny screw ups that we learn from every single day. And it's important that we have the space to do it. Screwing up is how we learn, or phrased a different way, you can't learn without space to screw up. For work recently, I was learning Rust, maybe for the first time or maybe for the third time, depends on who you ask. And I was just immensely grateful for a compiler that taught me how to screw up. Let me just bring up a little window here. And I'm going to open up some Rust here. Let's see if we can test my knowledge here. Function main is print line. I'd like to just print 2 + 2 here. Easy enough. Rust C main.rs. And the compiler tells me that I've screwed up, and the compiler helpfully gives me this hint here and says, okay, in order to not do that, why don't you invoke print line as if it were a macro? Okay, I'll do that. And it tells me, okay, I've screwed up one more time here. And it tells me, so the compiler is telling me that I've screwed up and has given me space to screw up. And rather than crashing the computer or something else, it instructs me how to not do that. So you can't learn without space to screw up. And I want to tell briefly, to put a little bit of context here, about a time when I couldn't screw up. In 2005, it was really, really expensive to screw up hardware. I was a kid, I was in high school. I knew I was interested in electronics and hardware and all that kind of stuff, and it was so expensive. I would go to Radio Shack and I'd get these like $10 resistor kits. And if I wanted to get integrated circuits, if Radio Shack had the one that I wanted, they were like $3 a shot. And so if I blew that up, $3 right there, right? And if I wanted to get something Radio Shack didn't have, I'd have to go online and order it. I'd go to DigiKey, and UPS shipping was like $20, and it would take like a week and a half for my DigiKey. Man, it was bad. And like if I wanted to fab out a PCB, back in 2005, the cheapest that I could do was advanced circuits. So that was 4 PCB, you might remember, if you were thinking about those kinds of things back then. And they had their $33 each special, which wasn't $33 each because you had to order 3 of them. So that was $100. And for your $100, you got 3 copies of a 2-layer no solder mask board. In 2005 dollars, so in 2020 dollars, that's $130. Anyway, so like what would you do? You know, you're a kid interested in electronics, out would come the laser jet that you got from the town dump, and I'd run inkjet photo paper through it, and I'd iron it on, and I'd get out the nasty etchant chemicals. And since I didn't have a soldering station, you know, I had this kind of Weller fire starter station. I'd solder surface mount parts in my mom's toaster oven. Hi, Mom. Happy Mother's Day. And the results were bad. Like I would end up with like very crispy boards. So I didn't make a whole lot of boards, and my skills consequentially never really got very good. If you can think about it, like you could imagine that instead of having a compiler that a second later gave you an error that told you it was wrong, it was a compiler that took a whole evening of work in nasty chemicals and didn't really tell you it was wrong, just had a bunch of things shorted together, and you blew up your board. So I'm here to tell you that in 2020, screwing up hardware is cheap and fast. Over the past couple of years, there's been almost an explosion of extremely low-cost PCB vendors. In the US, we have Osh Park. I think they're based out of Oregon. And so there, let's see, 3 copies for $5 a square inch. And it ships in 9 to 12 days. So, okay, sure. PCBWay in Shenzhen, that's even faster. And JLC PCB, okay, here you go. PCB plus surface mount assembly from $2. You can get anything in Shenzhen. All right. And so this whole thing, I didn't really believe it. I ordered some circuit boards. I designed a board. I'll hold it up to the camera in a moment here. I designed a board, and I designed it in KiCad, totally open source software. Here they are. I got them a week later. I'm just, you got me here just in time to put the finishing touches on soldering it here. So let me show you. I've got my little USB microscope here. I've got a soldering iron, and all I've got to do is I've got to get this voltage regulator right on here. You can see that it heats up. And while I'm doing that, let's just add a little more solder here. Come here, you. And you'll see that as soon as the part heats up, as soon as it wicks, you get this little sucking effect where the pad or where the part just lines itself right up on the pad there. Right, the reason why I'm wearing this headlamp is I can get a little extra light on here to help with these little tiny surface mount components. Come here. One of those, and one of those. All right. All right, perfect. Done deal. And the most exciting thing, I think the most exciting thing about a board bring up is, or about getting boards back, is the first time you get to power it on. So I have my little bench power supply here. You don't need a bench power supply to do electronics these days. You can get away with just so much less. Connect that like that. Gave myself 2 nice little pins there. The most exciting thing is powering it up for the first time. Oh man, that just went up in smoke real good. That's not great. That smells really bad. Oh man. Ha! Gotcha. I thought you thought I wasn't expecting that. I made this totally classic mistake. I assigned the pins on the voltage regulator wrong. It happens all the time. It just happened on a board that I brought up for one of my clients. Like the experts, the pros did this. And so like this kind of thing, it's so common. And this is the kind of thing you couldn't do before. And so, okay, here we go. Another week. Let's say I just fabbed out the replacement for this. And another $10 later, let's just go right back over to the cameras here. Put this one right under my microscope. Find that there. And so like previously, this would have been the end of it, right? I wouldn't have done another version of this board because it's so expensive and it's just so agonizing when things go wrong like this. Chasing it under the microscope. It's just so agonizing when these kinds of things go wrong. And, you know, it's just miserable, right? And so now that this didn't cost me, everything that I'd earned in a week kind of thing or whatever it was, it's a much different story. So hang on. So let's power this on this time. Power this, put that there, get one of those there, give myself plenty of power, and ooh, more smoke. Boy, that smells really bad. Oh God, tantalum cap smoke. Okay, so again, you can just keep making mistakes. This is the amazing thing that I just love about this process now that just totally wasn't possible. What happened there, I don't know if you noticed, is on electrolytic caps, on electrolytic capacitors, one specific type of capacitor, the little line, you can see it, I'll point to it, this little line on the end of the cap marks negative But on tantalum capacitors, it marks positive. And this is one of those things that, yes, you could learn, you could read the data sheet and you could learn that and all that kind of stuff. And you could, let's see if I can pick up another one and just place the replacement there. My hands might be too shaky and this board might get away without it. Yeah, I think this board will be fine without it. Well, let's see if this one works, huh? This is one of those things that you can learn either by reading Wikipedia and reading the data sheets. Hey, look at that, it's blinking. All right. You can learn it that way, or you can learn it the hard way. And the hard way is kind of the more fun way sometimes. That's kind of my claim. So in 2005, this whole thing would have cost me $200 and it would have cost me 2 months. And that's just for the boards, okay? And so for the parts, it would have been another $30 in parts or $20 in UPS shipping. And really what that would have meant is I would have given up before I even tried. And so the amazing thing is here in 2020, I ordered boards on a Saturday evening and they arrived on a Thursday evening from Shenzhen. And the whole thing cost me $20. I actually ordered both rounds because, as you may have noticed, that was a planned screw up, right? But okay, so that whole thing for 10 boards, 10 totally custom boards, 2 different designs in there. The whole thing ran me $20 shipped. And then the parts ran me about $30 shipped. I ordered those on Saturday evening. They arrived Tuesday evening. And you can do this at home. I used a hand-me-down soldering station from a former housemate and a hand-me-down power supply. You can get soldering stations for really cheap these days. If you're daring, you could cut open a USB cable and get you some 5-volt power. This microscope was $25 off Amazon. Why wait? Okay, what do I actually have to tell you here? Make mistakes. It's so important to make mistakes. And when you're making mistakes, that could be in the compiler, it could be when you're actually physically assembling things. You might tear something apart and rip a cable, and while you're trying to fix it, it happens all the time. You can't learn without it. Blow some stuff up, right? Don't get conservative in your designs because you're worried about not letting out the magic smoke. Let out as much magic smoke as you can. It's lots of fun. It smells a little bit bad. And the overarching thing here is that it's important to feel safe screwing up. It's important that you feel kind of financially safe in screwing up. That means that it's a $20 disaster rather than a $100 disaster. It's important with your compiler to not crash your machine. And so when Rusty complains about the borrow checker and this and that and the other thing, it's important to feel safe that you're not going to like overwrite your root file system. And so having those guards helps us experiment. And in human spaces, it's important to feel safe screwing up also. I feel like I love the Bang Bang Con aesthetic of we have the hard rules of things not to do, but we have these social rules of the well actuallys that somebody can come up to you and say, you just well actually'd them. And you go like, oh man, thanks for telling me. And you feel safe making a mistake because you know you can learn. Whether you're using Rust-C or whether you're in a soldering iron or in a real live space or a virtual space together, there's never been a better time to screw up. Thank you to all of you who stuck around to the end to watch. And thanks to the Bang Bang Con organizers this year who gave us a joyful, delightful, and surprising conference, despite all of us sitting around sheltered in place.
Thank you, Joshua. That talk, the live soldering was joyful, delightful, and very surprising. Thank you so much for sharing that with us. I don't think I've ever seen live soldering at a conference before, although I don't attend many hardware conferences. So props to you for doing that live on air. Yeah, that was not pre-recorded. I just want to point out that was live. Oh wow! Thank you all so much for coming to Bang Bang Con 2020. This year ran so smoothly despite our 11th hour switch to the virtual format. It is so energizing and so inspiring to see all of the work that people have done to make this happen. Could I get a huge round of clapping emoji in the talk channel, please, for all of our speakers who shared their knowledge with us this weekend. Just thank you all so much for presenting the work that you've been doing. I know some of these things took a long time and then you had to distill them into 10 minutes. So just a huge shout out for all of that work that you all have done. Thank you also to our sponsors and donors who made this event possible. And actually, I want to point out that for the most part, it's people like you watching the program right now who convince your companies to give us money. We don't actually have to do a lot of outreach, which is very nice. And please keep doing that. It is because of your work and funding that we're able to have such a well-run stream with captioning, with pay what you want tickets, and hopefully someday again in the future with catering. I did want to give a special mention to one almost sponsor who did a lot of work with us, which was actually Microsoft. And special thanks to M, who just spoke, for facilitating that. Before the pandemic, Xander's space, where we usually hold the con, was under construction. And some of you probably saw on Twitter, we went searching for a space that could hold us this year. We finally found and reserved the space at Microsoft's Times Square office. And then, of course, sadly had to cancel that. So a huge thank you to them for being accommodating and finding a space for us and trying to sponsor, even if it didn't work out in the end. Every year, I read Sumina's article in Recompiler titled "Toward a Bang Bang Con Aesthetic." And I do this for two reasons. One, I really like the word aesthetic. And two, it reminds me every time of why we do all this work to make Bang Bang Con happen. And the thing that really stood out to me this year, reading that article, was the part where Sumina talks about Recurse Center. But of course, she's also talking about Bang Bang Con. Here's the quote. "No one wins here. There's no leaderboard, and there is no ranking of people or projects. Whenever possible, the culture assumes abundance rather than scarcity. Attempts to rank projects or people would pollute the ecology. It's a pluralistic environment where we let go of dominance style objective ranking and instead celebrate a diverse subjectivity." I was telling my family about the talk on running TCP over the electric grid last night, and for the most part, that talk was about the electric grid, and I was thinking, just what a thing I never would have learned about. There's so many talks this year that go into things that I never would have even imagined putting together a talk about, and then being able to see that happen through this format and these little 10-minute snippets, these 10-minute windows into other people's interests and enthusiasm is absolutely amazing to me. And I really think that this idea, this post-scarcity optimism that Sumina talks about is beautiful. It means that we're creating this space where you can build tech and art for tech and art's sake. And we've worked very hard over the last 7 years and continue to work at building a radically inclusive space so that when people are here, they could really just be themselves and they can focus on this beautiful and diverse collaboration. And we find these, I might even call them emergent systems, that happen when we all get together and build something new and share these ideas very quickly and openly. And so I just want to take a moment and thank all of our attendees for helping us build this community. Bang Bang Con 100% would not be possible without all of you. So another round of clapping emoji in the Discord channel, if you would. It's a tradition of mine that I share a presentation. Let me bring my screen up here. And if Cindy, you'll put my screen into the chat. Oh, we can see forever. Another shout out to our sponsors, Xander, Kickstarter, 2 Sigma, Jane Street, and the Recurse Center for sponsoring us, Bang Bang Con 2020. I was supposed to be playing these slides already and totally forgot, so here's a picture of Sumina's article. But I'm going to tell the story about how Bang Bang Con came to be, and I'm very excited about this because it's always just a really fun story, and especially if this is your first Bang Bang Con, you'll get to see a little bit of what happened 7 years ago when we put this all together. So Recurse Center runs a chat room, and in this chat room called Zulip, we were chatting about this alumni week called Never Graduate Week. And Maggie, who is one of our original organizers, asks, "Are you all coming for this alumni week?" Alex, another one of our original organizers, "Yeah, we'll see." And Ian, who ends up instigating a lot more than he means to, says, "Yeah, my boss said that if I can find a conference in New York that week that's at least semi-work related, my company will pay for my flight. Potentially, maybe I can save some vacation." So, maybe we can come up with an excuse for Ian to get his company to pay for him to fly out to New York. And Alex says, "Well, obviously what you do is make up a nice conference website, pretend that you're going to this conference, and then get your company to pay for your trip to New York. Foolproof." Yeah. So Julia Evans, who you've seen and still is organizing Bang Bang Con, says, "Hey, you could organize a real conference by May if you wanted to have no time, probably." And Alex says, "I'll even do it for you so you don't get fired." Because obviously, and I just want to point this out in case it's not obvious, please don't tell your company that you're going to a conference that doesn't exist. That's a bad idea. Julia Evans has been writing amazing blog posts, and also check out wizardzines.com, I think is the URL. And so Alex says Julia Evans blog post cons. Allison says, "I would attend the hell out of that. Is there a CFP?" And here you can actually see that we have our CFP down below. Submit a talk. Requirements: must contain at least 3 exclamation marks in the title. Exclamation mark con. Really? Exclamation mark, exclamation mark, exclamation mark con. And Maggie gives us our name, Bang 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 Con. Julia says, "Yeah, I would go to that. I'm sad this doesn't exist." We need a website. Okay, Ian says, Bang Bang Con is a little easier to pronounce. It also gives us nice tie-ins with JavaScript. Thank you, Julia, and with running the previous bash command. Bang Bang Con is available. Great. And we just space and a chair, and there's conference thing. Here's our real CFP. I'm not going to read the whole thing, but I'll point out a couple of things about our original CFP. It has to be programming related, has to have an exclamation mark in the title. And originally, we encouraged Upworthy style submissions. Remember, this was 2014, which was a very different world. You won't believe this one weird GCC bug. We'll still take those style of submissions, but I think our taste has migrated a little bit. Got carried away. Sorry, we're not actually doing this. This is all a joke. Ha ha ha. Especially because Julia is not allowed to organize conferences anymore. Yeah, very busy at the time. So Alex is like, "No, I'm taking this joke too far. Of course, I'm going to register this." And Alex says, bangbangcon.com is in my cart. Registration imminent. Voice your concerns. 5 years. I'm confident. And I am so amazed that we have now made it 7 years. We did actually have to renew the domain, and I think we renewed it for another 5 years. So check in with us in 2023. Had to do some quick math there to see if we're going to renew that domain again. Alex, I am now proud owner of bangbangcon.com. Amaze, wow, wait, awesome. Did I just buy bangbangcorn.com by mistake? The answer is yes. Oh, so yeah, we now owned bangbangcorn.com. Popcorn related conference was well on its way. No, Alan, of course, chimes in and says, "Don't worry, it's just a pivot." Recurse Center, which at the time was called Hacker School, says, "We'll host, we'll be affiliated, but you all will actually do the work." Great, we're doing it. We're going to get Ian his ticket out to New York by actually organizing a conference. And that is actually the end of the story. We scrambled together a conference. I don't remember when this was. I think it was January or February when we put this thing together. And yeah, Bang Bang Con happened in May of 2014, and then for some reason happened in May of 2015, and it was all really just a joke that got out of hand. And here we are with this absolutely amazing community, a strong network of people and sponsors, and our amazing contractors who help us put this conference on. If you end up going back and watching some of the live streams that I did, literally just pointing my laptop at the stage, they're really not great. And Cindy and Confreaks have been doing such an amazing job of putting together our live streams since I think 2016 or 2017. We've been contracting out to them, and it's made it go so much smoother. And then adding Mirabai and Steno Night for all of our real-time captioning, and being able to make Bang Bang Con more and more accessible, more and more available, and more inclusive of everybody who wants to attend this conference, just about joy and excitement. And I just, yeah, thank you all so much for helping put this together. Can we get if any of the organizers are online, can we all pop into the room to say hello? Hello.
Hello.
Hello. I'm still thinking about Bang Bang Corn.
Yeah. So one thing we should mention is we actually did register Bang Bang Corn LLC, and that was our the like body that organized Bang Bang Con for several years. And so I just remember like Comcast wrote us a giant check to Bang Bang Corn LLC, and I just thought that was the funniest thing.
And we have more than one sponsor confirmed. Be like, are you sure it's Bang Bang Corn?
Oh my gosh. And actually, that my last slide, which I forgot to show again, is that we have now organized more broadly into this thing called the Exclamation Foundation, which you can find online at exclamation.foundation, because of course that's a TLD. And Exclamation Foundation right now organizes Bang Bang Con and then Bang Bang Con West, which happens in February in Santa Cruz, and was a huge success this February. Thank you all to the Bang Bang Con West organizing team. And then Exclamation Foundation is also in the future going to be where we're going to publish things that help other people organize their own conferences. So being able to a space for our materials for saying, all right, you want to run a Bang Bang Con like conference? Here are the mistakes we've made. Here's our Joshua style, burnt PCB boards. Learn from this. And yeah, I like to end the conference every year by also encouraging everybody who's watching to, if you have an idea for a conference, if you have an idea for a get together or an event or anything like that, it's totally doable. As you can see, this came out of a complete joke and turned into something very real and something that I really care about and really love deeply. So if you have those ideas and you have the time and freedom to chase those, I highly encourage you to do it. And you have support. Reach out to Exclamation Foundation, reach out to the Bang Bang Con organizers. We'll put you in touch with people and resources and contractors and everything that we use to make this a successful conference, and so that your conference can be successful also. And we've had a couple of people do that. Hey, Ahmed.
Hey.
Like StarCon in somewhere in Canada.
Toronto, I think.
Toronto. And Enthusiasticon in Berlin. And I'm probably missing a few others that are. Which one?
In Chicago, they had. I'm blanking on the name. But
It's like it's not StarCon. It's like QCon. God.
PromptConf.
Huh?
PromptConf.
PromptConf.
In Chicago.
In Chicago. Okay.
Chicago,
yeah. So be in touch if you're interested in running conferences with this format or really any format. I think some people are also doing like an interactive fiction thing, kind of spun out of this and stuff like that. So it's definitely we have some resources available for that. So please be in touch. You can get in touch with us on the exclamation.foundation website or the Bang Bang Con website. I think we've got contact details in both places. And on Twitter.
Being in the chat that Enthusiasticon Berlin is next month.
Yeah. Enthusiasticon next month. Awesome. Are they? Are they remote also, or are they virtual conference? Cool. So yeah, definitely check them out. Is there anything else that we should say before we close this thing?
Yes. I want to invite Mirabai to join us and
Oh yeah.
see. Hi.
Hey.
Hi.
Oh, and that's Cindy's cat.
Oh, cat. Oh wow.
Oh, what a sleepy cat.
Amazing.
Amazing. Thank you both. Normally we would like point you out in the audience and be like, hey, thank you for helping run this. But yeah, you both put in a ton of work behind the scenes to make this happen. So major props to you, and we'll of course put your website and everything in the chat and on Twitter. So
Nice. Thank you so much. Thank you for making this possible and inclusive.
Yeah. Okay.
Okay.
That's it for Bang Bang Con 2020. Thank you all so much for attending. And we will see you next year, Bang Bang Con 2021. And then, of course, Bang Bang Con West, which I mentioned, which should be in February of 2021. Check out our mailing lists, and Twitter will be communicating via those media in the future. And thank you all for attending again. Have a good one.